turn. So I will do that. And so here we go. As I start this up now, you may or may not get this depending on whether, and I don't know if this is coming from, this is actually coming from the Carlson side of the world. It's not coming from IntelliCAD or AutoCAD. Uh, but whether it does it under both platforms, I'm not sure. Pretty sure it might, but it looks at these files when you open them up, and this one came from, who knows what source. It was not originated in Carlson. And because of that, it did not have any units definitions applied. It did not assume it was working in US survey feet or meters or international feet or what have you. So that's what it's doing, is it's telling you that it's going to make the assumption of US survey feet and then remind you that if you need to change that, go to drawing setup. All right. So now, as far as the CAD system goes, of course, the units, it's completely unaware. It's just whatever you declare them to be, and everything is so many units long or across or diameters of. You could be working in angstroms, you could be working in light years. It doesn't matter to the CAD system, and it doesn't care. Um, but anyway, that's all that's for. When you get that US survey feed is fine for me. And now it's supposed to be this year that the American surveying industry is going to try to adopt the international foot um, instead of the US survey foot. I sort of doubt they're going to succeed in it. It's going to be like trying to go metric, in my opinion, but we'll see. All right. Now I'm going to bring out some toolbars here. And I'm going to have I had the SiteNet display. I'm going to choose SiteNet General and see if I can find where they went. Oh, there it is. And I'm going to just put these toolbars up here across the top. And the reason I'm doing that is a lot of people, may or may not use the toolbars, but it's actually pretty well containing, pretty well contains the typical workflow from start to finish of doing a takeoff analysis of a site. So you basically are fed the things you need to do from left to right, okay, across the various toolbars. And it's also the same as if you're going um, down this menu. You typically, going to start there at the top and work your way down, although it's not entirely correct because, you can do all these things in different orders, but you guys are probably aware of all that. Now, I don't think, do I have a third one? I don't believe. Um, there's takeoff. Oh, there's takeoff and SiteNet display. I've just got SiteNet out. So you see there's a slightly different one if you're using takeoff that would also do the same thing. And then just takeoff general. All right, so here's the comparisons. Let me get these ones. I'll keep the site net above the takeoff variation the same. Now that was in SiteNet, and I don't have an equivalent SiteNet reports. I don't think. Yeah, see, there's no SiteNet reports, but there is a takeoff reports, and this is where you can run, some of those reports to get your uh, bid processing done, that sort of stuff. So now let's take a look at a couple things while we're here as well. If I switch to the construction module, so this is as if I'm running the entire full grown-up takeoff version of this. Takeoff has this one tool in it right here called project checklist that you do not have. Now, it's not necessary because everything that you have to do, if it's not done, the software is going to tell you, and it's going to, remind you that you have to do this before you can proceed to do your work. But these are some of the little extra things that Takeoff has, or the construction module, that SiteNet does not. And things like this, where you have to define your layer targets, it's missing. Or you can set a boundary, that's been done. Or you can make the existing, hasn't done yet, design service, and sometimes it'll say needs to be updated. So, it's just a little things like that. And the takeoff menu, you see, again, you're going to have things like they suggest you running drawing cleanup first, then defining the layers, and then, control your display, then set your boundaries, your areas of interest, subgrade, topsoil removal, special fill, all of that kind of thing. Now let's switch back to civil for those of you who are running that, and you see you've got those similar type things here, just a little bit abbreviated, where you might not be able to do those full-fledged thing. We already saw how you don't have access to the colors when you're trying to work with the elevations. Now, this being the general for takeoff, this is the general for SiteNet, and you can see the first item there is to define your layers, surface, materials, that sort of stuff, and then set a boundary. Well, in takeoff, again, because it has a little bit more hand holding than the civil SiteNet tools, which is really more of a convenience to give you a little bit of the takeoff process. You see, it starts with, well, you better import a PDF file, then you got to run drawing cleanup, and then you get to define your layers and set your boundaries. So you can see that difference. In fact, let me pull this out to where those icons line up underneath each other. And so you can see that they line up underneath each other, at least for the first 5. There I've got material quantities in SiteNet, and there's my surface report in Takeoff. So some additional things where I can set these topsoil removals, set the boundaries. Here's my visualizations, just some different things that are pulled in. Here's my trench tools. And again, just the general type of thing, okay? I've also got this, there's my 3D drive simulation, same as this one over here. So anyway, it's just a couple of differences that you can see, and it's really not much that gets in the way that you don't have. You can still do all of these different tools. So but that's basically the, this is basically the workflow right here. You have to define the materials, you set a boundary, you make that existing, you make the design, and then you calculate the numbers, okay? So what do we do, or if you guys are familiar with it, it seems like, you guys have some experience with it. You've noticed, I'm sure, that, we typically define a list of layers that are going to control, hold what is existing, and then we decide what is, which layers hold the things that are designed, and then everything else left over is other. And so, you can make some inferences here that these contour lines are existing. Now, this particular file, and I think if you follow the tutorial instructions that are in the software, and you can get it either in this book that's part of your data set, this Carlson takeoff tutorial manual. It's included there, but it's also included if you look under the help system in your Carlson manual. Look under the table of contents, and if you look at the bottom of that, you have these tutorials, one of which is where would it put it? It's another nice little section there in the CAD basics, but there's this there it is, takeoff/sitenet CAD file from start to finish. So regardless, as they do this and they show you which layers and all that kind of stuff to set, they don't tell you the fact that, some of these contours are not right. And I don't think they're subtle enough to where they've intended that to see if you can fix it. But if you look at, I'm going to just spin this thing up for a little bit, and I can see, all right, I've got some, right there's a little depression contour, so that looks okay. Now, keep in mind, I'm upside down or sitting right on the area here. But here's, for instance, this is supposed to be a depression contour if it were all stitched together. This is supposed to be a contour. So here I've got crossing contours. Here I've got, some things that are probably, this, who knows what this is all supposed to be. And I'll go over to areas like in here, if I were to, let's look at this again in our viewer. And if I see I've got some things that are not, they're not zero, probably should be. But if you look at these, you get sort of a general sense of the existing grade, and that's okay. But if you look at this edge that comes down in this little, place where they've eliminated some information, I think, yeah, there you can see. And it's hard to visualize exactly right there, but this comes down at a different slope than that. And then you've also got this discontinuity over here in this back area where things, can be a bit of a problem. So here's what I'm talking about. If I look at the elevations of, all right, that's 820. That one is 819. So it's going down the hill by ones, starting up here with 820. Right beside it, if I choose that one, that is actually 821. That's 820. That's 815. So they've chopped out the intermediates there. And there should be 810, which it is. And then 807. All right, so see that went to 10 to 7 to 06. 805. So you can see it's just a jumbled up mess. And there's not a real lot of benefit in trying to figure out how to resolve all this. It's just, pretty poor mapping. Again, with, crossings and all kinds of things going on. So here's this. This is a contour that goes from here, wraps around, comes back this way, and then comes around this way. And then they pick up another contour, just a dead-ended line, and then another dead-ended line. So those are the kind of things that just can't actually exist. But so if you'll ignore those parts of this, this is the data set that Carlson provides. And then we look at a couple of other things. We have a polyline. If I select that polyline, you can see it goes all the way around the site, and it is actually it lives on a layer called perimeter. Just it doesn't matter what layer it's on, but that's the layer that has been assigned, and you can, oops, that. So, but that's one of the things that's required when you run this stuff through the SiteNet or takeoff method, is that you are going to have that bounding polyline. And that's what I was talking about before on yesterday, is how when they step you through all this to teach you these tools to elevate these things by different means, which is all well and good, but they put this boundary as this outer edge here, right up to the back edge of the parking lot. But, you know, that's, what do you do with that? You know, it has to tie into the ground at some point too. So, you know, and it could be a not insignificant little tie-in. I wouldn't just take this, you know, that's not actually a constructed line. That's just a drawn line that comes around these things. The constructed line would actually be the back of the curb. So you've got one line in this file representing that entire curb structure. You've got these elevations and leaders that are pointing to this curb structure. So you can see you got two elevations. You've got the top of curb. You've got an FS, which is, does anybody know what the FS might stand for? Here's an FL, which I would read that as flow line. So 16.00, 16.50 is top of curb. But I don't know what an FS is. I don't know that it matters. But we can very quickly go through here and elevate this entire curb structure, and then, you know, create that kind of thing for us automatically based on these labels. And again, this is what we typically have to do, is we have to interpret what somebody else gives us, and we have to use that to set our model. So let's go ahead and step into this process. And there's another thing. If one of these here somewhere that it has a label in it and it doesn't match, so disregard a lot of that. But anyway, let's go through that process we typically need to do. We need to establish the layer membership of our components, existing or design. So under SiteNet or under Takeoff, if you're doing it there, let's define the layer/surface, or the layer, surface, material, and subgrade. And we do that. You see there are three tabs at the top where you designate what becomes what. And you've got a list of, for lack of a classification, everything is considered other. So if I want to find out what all the existing things are, you know, I could find out what this layer is, and then to choose that, you know, decide to go existing or design. So We also have a screen button, a screen pick button. You can also, I'm going to exit that. You can go back to that and you can say not in SiteNet, but if you are in Takeoff, you can do it where you, I thought there was an actual command where you set the layers. Yeah, this is it, where you set the layer for existing. So you can actually pick from the drawing. So that's how you would do it in SiteNet, and then, or in Takeoff. And then of course it's going to, immediately update with the colors and show you that sort of stuff. If put this back the way it was, and I'll go back to civil. So that's not, see, all we can do is display. There's no set. And that's the difference in these toolbars. Although if you see this set layer for existing, this is the Takeoff display toolbar. This is the SiteNet display toolbar, and it has those tools in it. This is where you can pick them. This is where you display them. So if I pick,
Actually, under SiteNet, that pull down, there's actually a set layer target, and then it kind of is like a separate pull out menu, which is weird.
okay, where are you looking
Go
at?
up one.
Yeah, you have to go to the right. Yeah.
Oh, there you go. They've tucked it underneath it. Oh, okay. Yep, good call. So you do have it there as well. All right. And okay, so you could pick them there. I tend to like to do I tend to like to do this from the screen pick button from inside here, so I can see this happen as I'm working. So there's existing. Now you can also go over to your other, and you can find, now here's some depression. See, I didn't pick up the depression. So you find your index depression, your intermediate depression. So I'll just control click on that, I think. Yeah, and then I'm going to move to existing. All right, so there is that. Everything else is going to stay other, and I've got some design issues or design things. So I'm going to screen pick. I'll keep my building, this little plaza thing, whatever it is, that curb line, and I may be picking those doubly. I'll get some of that text. I'll get these. So I may, like I said, I may be getting things on the same layer more than once. It doesn't hurt a thing. Just making sure that I've got them all. And now you see that's picked these up as design. I've got some existing, some design, the rest is other. I'm going to save that. If I look at my display options in my display setup, it's cut and fill, existing ground surface. I want to show the existing entities, the design entities, and the other entities, as opposed to the contours or the surface triangles as well. And this is where you're just setting up, contour intervals and colors and things like that. Cut and fill, labels, color map, etc. Also available from the display toolbar. So that's there. I'm going to save. I'm going to exit that. And now I'm going to look at this and I'm going to toggle back and forth. These are my display tools here. So I'm going to turn off my other. So it looked like that was the outline. I'm going to turn off my design. And that leaves me with my existing. I'll turn that off. I'll turn design back on just to make sure, okay, was there anything else that I may have had? And I can tell something here immediately with this. It's this right back here. See this? This polyline, even though it starts here and goes all the way around the site, is not closed. That would cause a potential problem with running this process, because it needs these to be closed, enclosed boundaries that are going to calculate these materials. Okay. So the very first thing that I would do at this point is, maybe close that thing off. But let's take a look at something else. If I turn design back off, I'm going to turn existing on, and then I'm going to turn other on. Oops, except I'm going to hit the right icon. And I see, okay, I've got this piece of text over here that says asphalt, and I've got these red labels that I should probably put into existing. So I'm going to go ahead and choose that existing button. I'll get one of these red labels and this little word asphalt. And now I will toggle my other on and off. So now I turn other off, and it looks like the only thing I have, I'll turn existing off under other, is there's a boundary and there's something right there. See what layer that's on. Proposed gutter, PR gutter. Let's see. Ah, see, that was part of that hiding under there. I'm going to select that and just get rid of it. I'm not going to need that. It was just a duplicated line. Right now, what's another tool that I can use to get rid of potentially some duplicated lines? Anybody?
Would the drawing cleanup do that?
Exactly. Drawing cleanup can do that. And if you look at that, and you can choose to do it, if you have the takeoff, it's all under that menu. I don't think it's repeated under this menu. Is it under general here at all? I don't think so. Probably you're just stuck with it from the file menu. So it's always available anywhere. Now here's a couple of things to understand about this tool. It's a great tool, and it can do a lot of things all at once. Every one of these things that you can do in this tool, you can do individually with a separate individual command. But you need to be aware of, I wouldn't just go through and turn everything on and just hit the go button, because it's not necessarily going to give you the best results. So you've got buttons at the bottom. You can clear everything if you want. You can turn the defaults on. Now remember, these defaults are what the programmers decide that you should probably use. So I'd be a little wary of that. Now here's one of the things that I use this tool for more than anything else, and that's to evaluate and set my elevations. I already know that I have some things that are down. Remember when I spun the thing up and I saw this, like some labels and things? Let me cancel that and show you. It's these, if I go, let's go dead on to front. So up here's the mass of my contours. Down here's the bulk of things that are probably at 0. But look how I've got some things that are under 0. There's something that's over. And that looks like that's one of those curb islands, but it has an elevation already. It's actually 3D poly, but it's sitting here at 18.7 feet elevation when my site's actually up in here. Okay. So that's one of the things that I do before I do anything else. Is I come to that drawing cleanup, I clear everything out, and then I'm going to turn on The very last one, set elevations outside a particular range to 0. Now I can type a number in here and a number in here and let it go to work if I know what the numbers are. However, before I do that, and these numbers are left over from last time I ran it. So before I do that though, I'm just going to hit the scan drawing button and it's going to tell you, aha, you've got a minimum elevation of negative 4.2, it could have been 7.5 or whatever that, or 18.79, whatever that was that we looked at. But there are some that are below 0. So I can tell immediately I've got a problem. I know that the bulk of my site is around the 820 because I looked at the contours. So what I'm going to do is I'm going to use that information to just manually edit these elevations. So I'm going to set my minimum to, let's say, 750. I think there's nothing in here that should be 70 feet below this general, area that I'm working in. But just to be safe, I'll put, or even maybe call it, 700 if you'd like. And then there's an 800, maybe call that 900 as the upper end. So if you've got something that, is sitting at elevation 52,645, you're going to flag it. But so what will happen then is it's not going to erase those items. It's simply going to place them flat down at 0. And so that's one of the very first things I do. And I hit OK for that. And it said, hey, there were 22 things that were outside that range. We put them back to 0. So yay us. All right, now we could run that again and talk about some of these other items. And now I can even uncheck that. So up here at the top is the user coordinate system, setting them to world coordinates. And this happens a lot if you get files in from, say, architects that are, to them, let's say if this was an architect's building footprint that you brought into your site, the architect doesn't care so much about your site and whether where that building lives in the real world in terms of coordinate space, because to him, the building is the most important thing, just secondary to his own ego. For those of you who love architects as much as I do. And so therefore his world begins 0, 0, 0 at the corner of his building. And it lines up, the building is all square to the page. Everything's all, hunky-dory in his cartoon world. Now that's being, a bit tongue in cheek. There are obviously, and in particular now in the world of Revit and SketchUp and other tools that architects use to where they integrate with the site, they're becoming a little bit more integrated than that. However, sometimes you'll see that has been rotated and then they may deliver a file to where the user coordinate system is not assigned to the world coordinate system, which would match up with the real world coordinate. And you can tell that if you've got the icon on, you won't see that little square down around it there. So you could tell it to, all right, go ahead and turn it back to world coordinates. All right, so it doesn't hurt to have that on at any point, although I know that I don't need it here for this one just by looking at that. And here's another one. If you're working with architects, the architectural inches units convert to decimal format. And all that means is it comes in 12 times too big because, and for whatever reason, and I do not understand it, when Autodesk was first published and released to the public or to the practicing, professionals, they, I guess architects were one of the first and early adopters. And for whatever reason, they decided that they needed a special, they wanted to work in inches. So Autodesk was always from the start sort of unit agnostic. They didn't care if you're working in angstroms or furlongs. It doesn't matter. And that's the way we work. However, the architect said, yeah, but we want to, when we type in 36, we don't want that to mean 36 feet or whatever. We don't want it to be 36 inches so we know it's 3 feet. And for whatever reason, they decided to call one of their units architectural units where everything is actually done in inches. So, you know, we have that legacy that you have to work with, that everything comes in 12 times too big unless I tell it when I'm bringing it in that, hey, the source of this drawing's in inches and I'm going to be in feet. So it's just a little bit of housekeeping you have to clean up. That's what it's for, to do there. Now, I'm not going to, and this is why I say you need to be careful with some of these, is that you don't want to, you know, rescale your drawing if you don't need to do some of those things. But this one won't have that problem on the units because the drawing file units are set to be decimal instead of inches instead of architectural. So we're okay. If you have any external references that are attached that just for display, you can bring them into the current drawing as part of that drawing's geometry, because sometimes we need that as just native drawing geometry to work with. You know, so you can read all those. I'm not going to go through all of them, but a couple of things that we will talk about. And this is a new one here, relatively new, this remove unused registered apps. So if you've got a registered application that was in play, or somebody else had worked on the file before you got it, and let's say maybe they're using, you know, well, Civil 3D or Land Desktop or Architectural Desktop or something like that, some other registered application had produced some of the data, and it's keeping that registration hanging around. You can have it strip those registration codes out. I've never really encountered it, but for whatever reason, they've added that to it. And right there is your removing duplicate line work, and you can give it a particular tolerance. Now, I don't know, I haven't done a lot of extensive testing on this, but I think this is not taking into consideration layer membership. So if I have a line on one layer and I have another line or polyline or whatever that is just like it, but on a different layer name, I think it considers that a duplicate and it gets rid of one of them. Which one it gets rid of, I don't know. Maybe it gets rid of the oldest one or the one that was created, you know, the most recently. I don't have any idea. The tolerance value is how far, it's a distance, how far off you would consider it to still be a match. And this is actually a three-dimensional distance. So it does take into account the elevation. So if you have a 2D line and you've got a copy of that line, but it is sitting up in 3D, those would not be duplicate lines. Okay, so they have to match all the way across the board, except for layer and line style and stuff like that. Same thing with duplicate text, duplicate points, any of those. And again, these are CAD points, not necessarily Carlson points. Now, the overlapping polyline loops. I've never heard a good explanation of what that is, but I suspect it is this. I'm going to cancel this just to draw something real quick. If I had a, you know, polyline that maybe it was a represented a contour. Let's see if I can do what I'm trying to do here. Yeah, maybe it was something like this, which is obviously not how a contour should work. So I think that is what that is considered you know, an overlapping loop. And it would be handled like this. You would get something like that. And so it would take this and then close this one off, you know, in this regard, and then close this one off in this regard, so that they're still basically the same, you know, relative elevation, but it's taken out the overlap. Now it could have done, you know, that direction, or it could have done like this and then like this. So it's, you know, how it decides, I don't know. But back on to sort of those line work with the same endpoints to join those up. That's where you got to be careful, because sometimes you get lines that, you know, more than two that share the same endpoints. I'm going to go ahead and turn it on for this file because I've got all those little segmented contours. I'd rather take a look for it than if I run into a problem. And now splines, multi-lines, and regions, to go ahead and, you know, dissociate their additional complexity down into polylines, because sometimes I need, Carlson, you may have noticed, likes working with polylines. It likes to use polylines more than anything else. And in fact, I've gotten so used to it over the years that I don't even ever draw lines anymore. I always draw polylines, even if it's just a single segment. And if I need it to be 3D, which is one reason why people draw lines, I can draw a 3D polyline. You know, I don't have any problem doing that whatsoever. So that's just something to keep in mind, and that's why you see tools like that to offer to convert things into polylines. There's also, if you draw a circle, now a circle is not a polyline. It can be turned into a polyline, or you can create what is essentially a circle by drawing, you know, drawing a polyline by a couple of arcs that basically, you know, the two halves of the circle. But we need to use polylines to do things like, if you think about a road alignment where you've got a roundabout and you're trying to define the center line around the roundabout, around the circle, the software can handle that just fine, but it can't handle circles, and you have to convert those to polylines. And so that's why you've got, you know, this little guy down here to convert those. Now, any of these meshes, I've never really run into getting those and needing the faces, but, you know. And then any civil 3D or land development desktop, AEC, which stands for Architectural Engineering and Construction, contours and points. If they happen to be included here, turn those into Carlson format. You could do that all at once at the same time. Convert any entities with extrusion, those would be extruded solids, into world coordinates. You don't convert an entity into a world coordinate. It's sort of poorly written, but I think what it means is to explode it out and then create the resulting solid as the component wireframe. Members, this is a relatively new one. Invisible entries, turn them visible so you can erase them. I'm going to erase any blank text. Hatches are typically done just for visual stuff, and they can sort of get in your way. You can choose to erase them there if you'd like. Erasing any zero length and fragmentary line work, and there's the tolerance value, so it has to be smaller than 100th before I consider it a little fragment that needs to clean up. And this removing arcs from polylines and 3D only, this is sort of weird as to what they're asking you to do. We talked about that removing arcs function yesterday using the maximum offset or the chord length. as a setting in our Carlson configure general options. And this is sort of talking about the same thing, but it's not exactly, because this is actually doing the work prior to setting that into a 3D entity. So if I've got, again, let's consider the edge of a parking lot, but if it's all drawn down at elevation 0 and it's got an arc in it, and if I turn this switch on, I say remove arcs from polylines. If I uncheck this, it's going to take those 0 elevation polylines that have arcs in them, and it's going to go ahead and convert that arc into those chorded pieces and leave it at 0 and keep it as a 2D polyline. This little switch right here that says 3D only, this is the confusing part, because remove arcs from polylines, if you said, oh, I'll only do it from 3D polylines, well, 3D polylines cannot, by definition, have arcs in them. You know, we've already talked about that in terms of and even if they're all at a constant elevation, if it is a 3D polyline, it will not have any arcs in it. The intent of that little checkbox means polylines only look at the polylines that have elevation. So like these contour lines, they have elevation, but they're not 3D. They're still planar. They all live in the plane of that single elevation. So that's whether or not you want to go ahead and pre-strip the arcs. I tend to not do that unless I need to convert it into, those segmented edges. One of the reasons you might want to do that ahead of time is that if you've got, let's say, considered some pond contours, as you get to the corners, maybe you've got little arcs that are turned into, the arcs are making that corner joint smoother or whatever. And so if you go and then model this surface by reading those contours, when it reads those polylines, and if they have those arcs in the corners, it will, the triangulation will use the arcs. But if you happen to have the switch turned off that says to densify your polylines, you're only going to get triangle corners forming at the start and stop points of those arcs. You will get no triangles that point up into the actual shape of the arc itself unless you have the densification turned on with the length shorter than the overall chord length of the arc. All right, so hopefully you're not completely lost out in the fog by what I was just rattling off. But anyway, that's why that switch is there, and you might want to go ahead and do it. I tend to not do it. I like to keep my arcs because I don't have any control over this. If there's an arc, a non-zero elevation polyline that's still 2D polyline, has an arc in it that I might want to keep. So anyway, you can do that as well. Reducing polyline vertices, again, not really a need unless they're just real super tight and you want to strip out those extra points, and you can set that cutoff so maybe it'll keep your file size smaller. So there's like 2/100ths if it's within that, and therefore it doesn't need it. I'll go ahead and do that. Set negative polyline thickness to 0. I've never seen something with a negative polyline thickness. I'm going to go ahead and have it do that just in case it encounters it from a different source. Same thing that I see up here, this guy right up here, remove a 0 length line. Now, that sort of doesn't make any sense. Well, if the line is 0 length, it's not there. but a zero length line is mathematically a point. And in fact, in the older versions of the MicroStation software, all the way back from Intergraph on forward, they did not use points. I mean, we as users treated them as points, but they were just zero length lines. So because they didn't have to define, a point as an entity separate from line work, they just said it's still just a line, but it just simply has zero length. So sometimes you'll get some holdovers from that, and that's where that phrase, a zero length line, comes from. All right, so we're good. We've got our elevation set, 700, 900. We've going to do the entire drawing. So we're going to say okay, and off it goes, and says for a more complete conversion of custom object, you recommend saving first to update the object to the latest version. Okay, go ahead. We'll save. And then it finishes looking for those custom Civil 3D and land development desktop. And then we'll say, go ahead and continue and let it finish. And now here we go. All right, no splines, multi-lines, regions, but look at that. 184 entities with extrusion into world coordinates. And I have no idea where and what those were, but it took care of some of them. 2,900 of these polylines. No conversions from these third-party software. Joined up almost 2,500 little pieces of line work. No invisibles, no blank text. 57 from 4,000 total polyline vertices, so it weeded out a little bit. 12 zero length or fragments, no negative thickness, and 174 entities were outside that elevation range, made them down into zero. And there we go. Now we have the scores, and you see they're no longer in those individual pieces, but what else happened there? Or these are. There you go. They don't have the same line, the same endpoints. Okay. But you can see, this has an elevation that's what? 817. This one is 817. Why didn't it? Yeah, 817, 817. There we go. And this one is probably also, there it is, 817. So, you could go through and fill in those gaps. It's just a real sort of hassly looking thing. So, as we take a look at this in our 3D viewer, or we can just, look at it like so, we know where we're going to be getting our existing information. Our existing surface information is coming from this. It's going to be pretty spotty. That's a pretty crappy set of source data, but it's there. Now I just went back and did a zoom extents and everything disappeared, right? I'll tell you why. If you look at, well, okay, it's going to make a liar out of me now. All right, so there we go. I did a little zoom extents. All right, I'm not seeing anything. If I zoom around 0, I'm not finding anything there either. Sometimes a command will leave a point assigned right at 0, 0, 0. That's not the case. All right, so I've got something somewhere that's not showing up, and I can't seem to get my way back to, and that happened as a result of that drawing cleanup. So I can't seem to find my way back to that zoom. So there's a couple of things that you can do to help do that. If you go ahead and do a zoom extents, and then I'm going to roll the wheel forward a little bit so I'm zooming back, out a little even higher. I still can't really see my stuff too far away, but if I type the word select, and then I type ALL for all, hit enter again, sometimes you will see those things show up and you'll see the grips show up. Now I can see over here that my grip limit was reached, so it didn't show up here. So it might work in AutoCAD better. All right, so that doesn't happen. So what happens is you'll see the grips light up, one blip for some stray item, and then, all these blips for everything else over here, so you know how to get your way back. All right, so there's another couple of things. If you do a zoom, look at some of the options here at the bottom. You go in and out, all, center, dynamic, extents. Extents we use quite a bit, but left, previous. Now I can hit previous, and if I keep running that command over and over and over again, I'll finally get back to where I was, but I may have gotten too many away. But by window, then by entity, if I say EN, it says select entities. Well, let's see if I did all. That's still not going to give me a C. So now this is the IntelliCAD or the AutoCAD equivalent version of the zoom command. So there's no way, I don't really know much about it, but look under the Carlson view menu under that zoom. And now they have this thing here called most. Okay. So if I say zoom most, see, it said it found 876 items, but it found 8 outlier points. So what do you want to do? You want to zoom to the most stuff, or do you want to zoom to the outliers only? Well, let's go ahead and try the zoom most, and well, even at that, it didn't get me back. Let's try zoom most again, and now go back. Let's try the outliers. Huh. Well, this should up there. You see what happened? I dragged a window around it, and I found a couple of things here. And if I zoom in there, I see, wow, there's one line, and they're both on this layer called index contour, that one there, and then this one up here. So I'm pretty sure I don't need those. They're just maybe got displaced from where they were before. So those are the only two things I have selected. So I'm going to get rid of those and then do a zoom extents and see if that pulls me back. No, not quite. So anyway, I'm working my way around my site. Let's go now. It's still got 4 outliers. So if I go there, I'm going to try to see if I can snag a couple of those things here as well. I don't see that I've done it. Here's a couple of things here. So I'm going to see what, first of all, they are. I see there are 2 polylines. This intermediate contour layer, let me get back and snag them up again. So that's just one. All right, I've got 4. So that's the one, that stray contour there. Looks like a stray contour there. Now, why it blew all this up, I don't know, and yours may not have. That's probably due to that extrusion issue. All right, so those are 4 I don't need. I'm going to get rid of those. And now I'll do a zoom extents. It still has me out in left field. I'm going to zoom up most again. Now it's found 10. So I'll go to the outliers. Now, the way this is supposed to work with most, for instance, is it would, if there's only like a single straight point somewhere and you've got the bulk of your drawing clustered around a certain area, it should center the cluster of most of that data. But I'm finding it's not doing it with this one. All right, so there's these 5 stray polylines. Let's see. All right, so it doesn't look like anything vital there. 1, 2, 3, 4, 5 polylines. Okay. Close that. Extents still. I found something. Flagged. Hmm. Well, let's see. This says I had 3 new events. Selection set count exceeds the grip object limit. Okay, nothing I need to worry about there. All right, if I zoom most again. Oh, good Lord, this is chasing down. Oh, man, polylines down. What's my coordinate space? Like, those are like state plane coordinate levels. Hmm. Maybe. Wow, I don't understand where all these things have come from. It's done. That just illustrates the point of that drawing cleanup. You need to sort of be careful of it. If you get into a situation like this, that tool of zoom most, let's go to most. I still didn't find. All right, let's go to outliers. I'll zoom out a little bit. Found 2. Outliers. Let's go to most. Nope. Still. All right, go to outliers. Do a crossing selection of everything on the screen. This is just wind up chasing our tails in. All right, so I'll tell you what I'm going to do is I'm going to close the drawing without saving it and go back to that original. If you happen to have already saved it, you can either go back to the original, if you kept an original copy of the data set, that'd be fine. All right, so there's now nothing's joined up. I'm going to see my surface list that has remained, so that's great. I'm now going to do another thing that I probably should have done even before this drawing cleanup is I'm going to erase outside because I know there's nothing outside here that I really need. So I'm going to close this. Everything I want's included in that box. So now everything outside of there has been erased in case there was some stray figure. Let's go back to now running drawing cleanup. And let's not convert these extrusions. I think that's probably what might have caused our problem. We'll see. All right, go okay. And there we go. We come back with the report. Zoom extent, yep, and it is. So I'll now save that. That's in a good spot. Huh. I have no idea what those extrusion elements might be. All right. So if we want to declutter our drawing, I'm going to turn off my existing and just work with my design. And I'm going to even analyze a couple of things here to make sure, because I know I need closed polylines to help define some of these materials. So there's a tool under our polyline utilities that will say, let's see, and it's under check polylines. And this, we can tell it to highlight certain ones. And the ones I'm looking for, now here you can see crossing polylines, you can check for your contours crossing. But here I want to highlight any unclosed polylines. And it says select the polylines to check. Well, I'm just going to say all. And you can see that outer edge is now highlighted. It's dashed up. Plus all of those little labels. Do you see the leaders for the elevation labels? They're also not closed. Some of them are just sticks, but some of them have two segments. And if we were to say close everything that's highlighted, it would try to close those leaders. So we're not going to say all. So you want to close all or just selected. Let's type selected. And so now pick the polyline to close. Well, it's that outermost. And if I did that, see what happened up here, how it closed across that gap. But what did it close with? Was an arc, right? Because it came here and had an arc as the last piece, and there was an arc coming in here. So it decided that part needs to be an arc. Now, how would you fix that? Using your grip edits, if you select it and get the midpoint grip and right, or just hover the mouse, then you can convert that to a line. You convert it back to a line. What else could we have done? Obviously, we could have drawn a line across, joining the endpoints, and then joined nearest so that we could join that together. So now I've got everything's closed. These islands, this line, the building, what have you. So what we will do next is to create the, we're going to elevate these items. Now notice the labels on this, like top of curb, flow lines, etc., are written as just the 18.5, but the building is at 818.7. So they've just out of convenience left the 800s off of these. The same thing on this pad. So just be aware of that, and we'll set these things accordingly. Now, what we can do with these two guys here is take them individually, go over to our property, set the elevation. That's perfectly fine. But we also have in our 3D data menu that we can elevate these by interior text, which, wouldn't make sense for these two little ones here. But if we do a pad polyline by interior text, so you can trim any elevated polylines inside the inside the pad. There's and the reason you would do that is in case you had contours that are crossing and go through your buildings, you might want to use that to trim those off with. You keep the original. Since these are going to just be up at elevation, they will remain 2D. I'm going to leave those. No need to keep them. Now, offset the elevated polyline, interior, exterior, or both. Now, can you think of why you might want to do that as an option? This is sort of a, think in terms of the offset, a 3D offset, like when you're building a curb or something, or a wall. So let's say we have a wall represented, by some polyline or this building, and you're doing the actual base of it, and then you can offset that to the inside or to the outside and give it some additional height that you could actually build a 3D model out of it. That's one way of doing it. You could also take your building footprint or building pad and consider it to be the basement elevation. Maybe you've excavated to that level, and then you want to offset to the exterior a certain amount, add the elevation, then that would be the actual ground line, whereas the pad elevation is going to be the bottom of the excavation for the basement. So there's a number of different reasons why you might want to use that tool to do that as well. So the offset amount, I'm not going to do any offset. My snap tolerance and elevation to add to text values, nothing. For the one that I'm going to do, the big building, I'm going to say okay. I will now select a layer sample of the text and select a layer sample of the line work. Okay, now all I'm doing is pick one at a time, and it needs to know which layers to consider. And then it says, okay, do you want to select another layer sample for other boundary line work? Right now, no, I do not. So I'll hit enter. And now it asks you to select a layer sample of outside elevated polylines, which I'm going to just hit enter because I don't have any, but that was because that switch was still left on to trim those lines. And now finally select the text and the line work that you want to consider. So it's just these two guys here. And now if I look at my building in my properties, I see it is at 818.7. So I can simply repeat that pad by the interior text. I'm going to uncheck that trimming, and I'm going to add 800. And I'm going to say, there's my sample text. There's my sample line. No additional. And then I'm going to just select those two. And now this one is at 817.56. All well and good. Okay, so we're going to do a similar thing to elevate this curb line based on these these labels with leaders. Okay. Now, here's where this can really be helpful and to be a quick process is we have a single line that's representing a structured curb that really has three lines to it. There's the face down on the asphalt. There's a top, which is nominally half a foot vertical above it. And then we have the back, which is half a foot behind that line itself. So we can do a couple of things. You can, pre-offset this right now is a 2D polyline, and since it's 2D, I could go ahead and offset the 0.01 or 0.05 or whatever I'm using for the top, and then the 0.5 for the back. I could pre-draw those all three lines and then elevate them individually, or you can elevate one and then do that 3D offset, because it will now no longer be 2D, you have to do a 3D. But now consider this. If you look at most of these labels, top of curb and flow line, you're going to see a half foot of difference. So 1572 to 1622. That's a typical type of curb. But if you look at, let's look over, say right in here, this parking lot. You've got, there's a half foot right there. There is a half foot. There is not a half foot. That is 2/100ths. Okay, so what's happening here? Here's now back to a half foot and back to a half foot. So what happened here, do you think? And that is a depressed curb. So that is like a handicap ramp. Now it's not very well defined, obviously, but what we would do, instead of just doing this once with just using the flow line elevations and then raising it all up half a foot and pushing it back half a foot, we got some that don't raise up half a foot in all places. So we can't really do the set this one and then do the 3D offset. We need to go ahead and offset and then let the labels govern which line we're going to be using. Everybody follow that okay?
Yep.
Okay, good. All right, so let's go ahead and, since this is 2D, we'll go ahead and do our offsets, and we'll offset to the outside of our parking area, to build this curb. We're going to lean it back toward the outside. So we're just going to do a standard offset under Edit, Offset, Standard. And of course, this will not work on 3D line work, but we're going to specify a distance. So I'm going to go ahead and I'm going to lay it back. I'm going to say, put me a layback of 1/10 of a foot. And now it says select the entity. So I'll select that outer one there, and which side. I'm going to go to the outside, and there now is my top of curb, which would technically, this corner or that leader for the top of curb would now be pointing to this up here. The FL, that's my flow line, that would be this interior corner here once we get ready to use it. Okay, so there's my 1/10. I'm going to repeat that offset, and this time, instead of saying 0.5, I'm going to call it 0.4, just so that the total width stays 0.5, and I'm going to take the last one that I did and go to the outside. So now I've got curbing all the way around on the outside perimeter. I need to do that for this line as well. So I'll do that. Go back to 0.1. And then back to 0.4. I'll zoom in here and grab this one. Okay, and I got two more I've got to do. One is this island right here. So I'm going to offset by 0.1 this to the back. That's by 0.4. This one, the back. Okay. Now the other one that I have is this one up here. So I'll offset 0.1, grabbing this, lean it back, offset 0.4, grab that, lean it back. Okay.
Hey, Ken, when
Yes,
you're
sir.
elevating based off the text, does it matter if the text is M text or just regular text?
No, it doesn't. In fact, it can be, I think it can even read inside blocks. I know it can for setting contour elevation by reading spot elevation text and stuff like that. So I think that part's really all it needs. Now, all of these things, if you, just as a test, I'm going to isolate this layer. And see, that's what I thought. All of that is all on the same. So they did not separate that out by layer. I've also got a couple little things that don't quite add up here. I can see that one right now. I'm going to fix it immediately just with a standard fillet of a radius of 0. Now I'm not going to try to track all this down. We'll see if we have places that miss it. All right, so I'm going to restore my layers now that I had. And remember, I'm only viewing my design. Oh, I can turn off my other. Need that outside the boundary there either. Okay, so we've elevated our buildings. We now need to elevate our curb structures. So we're going to go to our 3D data and we're going to, listen, we got these, convert spots that we don't need spot elevations. We want to 2D to 3D is what we want by text with leader. All right, so now it says, let's look at the options first while we're here. So I'm going to choose that O, and it gives a place to give a tolerance. Well, right now I'm going to give it a tolerance of just say 0.15. So if I'm within a tenth and a half, and that's to accommodate the issue of these leaders not pointing to the actual, not snap to the actual points necessarily. So we're going to do it this way as a 0.15. This is the maximum distance between the leader and as a scalar of average text height. Boy, they really know how to confuse that. The maximum distance between the leader and what? And as a scalar of average text height. Well, all right, let's say, okay, that was a lousy thing to put under options, and that's the only thing they had. All right, select a sample of the elevation text. Well, in our case, it's here, just any of those texts. And a sample of an annotation leader. Well, there's one of those. Again, it's reading the layers when I give it these samples. And next, it wants a sample of a polyline to convert. Now, this is where, let's see, it's going to look for that. And again, it's just the layers that it's reading at this point. So now it says select the polylines to convert and all the leaders and all the elevation labels we want to process. Okay, so I'm going to just select all, ALL, hit enter, and hit enter. One more, well, actually, no, I'm not going to hit enter twice, but I'm going to consider everything when I typed all. But now I'm going to type R to remove, and I want to remove, say, my 2 buildings. I'm not considering those, although they're not on the layer, so they're safe. But I'm also now going to I'm only going to do that inside line of down on the pavement. So I'm going to click these two outermost on and get on both sides of my parking lot and do it for the two islands as well. So one here, one there, and back here. So now the only thing that I am converting is that inside down on the pavement face of all of this line work, okay? So I'm finished my selection set, I'll hit enter. And it says enter an elevation to add to the label values. Well, that is 800 because of the same things. And now, because I've got a bunch of different little prefixes, none, but suffixes, I had all of those FL, FS, PAD, and TC. So the only ones I want to use in this regard are FL, which is my flow line, and also the FS. If you remember, I saw some of those and they appeared to be the same as the flow line elevations. I have no idea what that stands for, but that's okay. Now, you could have individual ones of here. Let's say that 800 was, I could put these offsets in here to, even after I've read the elevation, added the 100 or the 800 feet to it, but then I could put in like a negative 1.5 if I wanted to read all of that stuff and then drop it a certain bits. That's why I have this in here twice. This is not an amount to add to the text. This is a way of not having to calculate that difference. Instead of saying 800, you might say 798.5 or whatever. So that's why that works. But I'm going to only consider the FLs and the FSs. I'm not going to consider the top of curb or the pads. Okay. So that's all good. I don't need anything other than that. I'll say okay. And so it's going to go through. Apparently it read everything correctly. And let's see, indeed, if I spin this thing up, well, look at that. It did elevate it, whether it did it correctly or not. But I can see that it is, in fact, elevated. So I'm encouraged by that. Let's go through and see here. This one, if I select that, and I'm going to hover the mouse right in that grip, and then look down here at the bottom at my coordinates, and I see that that has an elevation of 814.43. True enough. There it is. And here's an 814.88 on the flow line. And 1487.94, true enough. And again, flow line here. 96. Now here's an FS. 814.99. Wow. I wish I understood what it meant, but I don't understand their terminology, but it seemed to have been everything we needed to do. Now, the next line we're going to say, we're going to repeat this command, which was ELEVFL. Okay, so we're setting the elevation by texting the leader, 3D data, 2D to 3D by text with leader. Okay, so select a sample of the text, a sample of the leader, and a sample of the polyline to convert. Wouldn't really matter which one you're choosing there. Okay, and now, oh, sorry, I always do that. Select a sample of text, a sample of the leader, a sample of the line, and now without hitting enter, that's the problem I did. It says select the polylines you want to convert, the leaders and elevations. So again, I'm going to type all so I don't have to go through and meticulously pick the text, and I'm going to remove certain ones. And I will remove the back of curb and the face of curb on all the structures. That's the outside. Here is the inside edge. We'll do it up here as well. The outside, the inside. Side, inside. So now the only thing that I should see highlighted is that top of curb line, and I see it on everything I want. Those are, you can even take out that pad text. Those, but they weren't on, these two buildings weren't on the same layers, so they're not going to be considered. All right, so that should work, and I'll hit enter. And ask me the elevation adder. That's at 800 feet. Now, at this point, the only one I want is my TCs. At top of curb, I'll say okay. And off it goes. Now let's see what may have happened. If I select that particular line, now notice there are two little points there, and that is 815.1. I see that's correct. That's an 815.1013. So it's done some things about it. Let's take a look at this now in our 3D viewer. And not only that, I'm going to give this a near stupid exaggeration of say 10. Because I want to see if it sort of kept everything sort of parallel. Ah, see right there, I've already found a problem. See that in that back corner? That should come down. And I'm thinking, you know, if I take that and bring that down, I should be able to tie that in and keep it relatively parallel. Now I'm just looking for some major gaffy problems. And I think that's really the only one. I'll put my exaggeration back down to 1. And so let's take a look. Okay, over there's my problem. So I think if I just bring that down and tie that corner, that'll fix that. And now let's take a look at some of those. You see this, how that curve comes down and then comes back up? That was that, whatever that little, you know, it's supposed to represent a depressed curb. And my guess would be that this comes down and it should stay down all the way down to here and then come back up. But they're only coming down to a single point and only coming back up to a single point based on those labels. Okay. What else might we observe here, if anything? I think that is up there's another one of those little ramps. I'm going to zoom back out. Scroll this around a little bit and take a peek. Okay, so there's another location where you can see that dropping down to that single point and then coming back up. And again, I think it should probably be, you know, a portion of it should also stay flat. Now, we're not going to fix that. We're not going to spend our effort trying to second guess this and trying to resolve that because, first of all, as you guys are well aware, you can't reinterpret this stuff, you know, too far beyond what the engineers do. You simply have to, you know, call in with an RFI so you can get them to tell you. And they may say, oh, well, yeah, it's a standard type 1 curb, you know, ADA access on the curb. So, okay, well, that clears it up. But if not, then they need to tell you that, oh, yeah, we either forgot to do it or this is how you handle that. All right, so now we don't have any labels and leaders to set the back of the curb. Other than we do see the top of curb elevations, the assumption is the back of the curb is going to be even with that. So what would we normally do in that case? Because we can't use that same approach. So what is that elevation? 1669. Yeah, right. So instead of trying to set the elevation 2D to 3D by text and a leader, we already have a reference. We have that line. So what we need to do at this point is a 3D offset. All right. So now here's the other thing. This is another reason why you would sometimes normally keep a set of lines down at 0 elevation. If you were producing drawings from here, or if you needed to know this radius value, you see this line that I haven't elevated yet, that still has a curved segment, and it therefore can produce a radius. That line does not. That's been elevated, therefore it's been corded, if you will, to simulate that arc coming around the corner. So now you can also see the effects of those numbers when I said do that, can remove 3D arcs, is I'm using that maximum offset of 0.02. You could also have it be, you could use the length if that was your preference, because if I look at this length here, that is what, 0.65. So if I had said in my Carlson configure general settings, instead of using the offset, if I had said use the chord length, I would get more chords here to where they're only 0.25. Now, in this case, they're 0.65 because the radius of the original curve was such that I still managed to satisfy this criteria, the 0.02. Right. So, not anything to try to remember, but just to understand, what set that up. All right. So now, if we do a 3D offset of 0.4 and 0 vertical difference of that top of curb, we're going to get this elevated line. But I no longer really need this 2D line, do I? Because remember, I did the initial offsets thinking we're going to elevate them individually, but this one I don't need yet. We're going to create that with the 3D offset. So I'm going to get rid of that. I'll zoom over here and get rid of it on this side as well. And I am getting rid of those 2Ds with the arcs simply because, my job here is to build this thing. It's not to produce a set of drawings. So I'm not worried about having to label that. I'm just really more concerned with creating the model. All right, so now I'm going to, look up here. What do you have? We've got this, which sort of jumped out here instead of creating this around as an arc. And I probably, if you go back and look at the original, there is, see, I'm setting this 1850 top of curb all the way around to the 1792. So that really needs to follow itself all the way around to here. Wait, 4292, 5800. Okay, so that's truly half a foot all the way around. Okay, so a couple of ways you can, if you get something like this, you can erase this segment and try to, throw something else in there, or you can, like I said, based on these elevations, I see that everything is all half a foot higher all the way around. So the easiest thing for me to do is, since there's no, differential elevations there, is I'm just going to delete that one, that whole thing. And while I'm here, I'm going to go straight to that 3D offset, which is on my polyline toolbar right here, or it's under edit 3D polyline utilities, offset 3D polyline. I'm going to go by interval, say okay. My horizontal offset amount, remember I'm going 1/10. My vertical amount is 0.5. Select polyline offset, here it is, and which direction? Over here. All right, so now I've got that exactly 1/2 foot up, just as if we did the labeling, but we didn't get that goof going around the curve. Okay, and I can repeat the command and go ahead and set in the back of curve. This time the horizontal is 0.4 and the vertical is 0. And all right, so I finished the island. And so might as well look, okay, didn't have a problem on that island. So now if we repeat the command, we can keep the 0.4 and the 0 and go there. We've done that island. Now the command's still running, so I'm going to come back here and do this one and go over on this side and do this one. And that's all good. However, I did forget up here. Remember we had that problem? We needed to fix that. And so what I would do myself is go back to the top. I'm going to take a look at this in my 3D viewer and get myself positioned to where I think I can see the endpoints correctly and which line that I need to tie them to. Then I'm going to go to my settings tab and I'm going to hit my little button here that says set your CAD view to the current view. View is now set. I'm going to exit. And now I'm going to have to zoom in and out, but I'm still pointed in the right orientation. So there it is. So now I know that this right here is connected. You see how that comes down and hits that bottom line? Well, then this needs to connect down to there. So I'm just going to grab that and have it snap, and I'm just hovering. I have my endpoint snap on, so I'm going to do the same thing now with this outermost one. And so now let's take a look at that. I may or may not have done that very correctly. All right, I did not do it very correctly indeed. Let's get, this is the face down among the, okay, it did what? Connected up to the right pieces. Let's delete these segments here and see if we can fix this. All right, I am back in my plan top view. So the problem is right here, this needs to, see, these are too short. They're pulled back in here short. If we were to, I'm just going to draw a 2D from here. Try to find there's the end point. I'm going to go here to this other end point, and then I'm going to go for a distance of 20 feet. And I'm going to go and angle. Now here's my choices: northeast, southeast, southwest, northwest, azimuth, or an angle left or angle right. Now, if you consider yourself surveying here, I backsighted this previous point down there where my leader comes in. I moved up to this point, and so now I'm going to go an angle right of 90 degrees. So I'm going to make sure that is a 90-degree face. So my angle right code is a 7 because I read the line above, and the angle is 90. Okay, and I'm going to type Q to quit that sub menu and then just quit that up. So that is the line we're going to actually make things parallel to. So I'm going to now take this out here and get rid of that vertex. So that's now at least something I can go parallel to in my 2D. So if I do this correctly to close this off, let's see, I'm doing the inside face. So I need to keep these. Let's do, see if I move this to right here. That's my inside. If I intersect that, but then, yeah, see, that's got to come way out here to where it's at least a 1/10. All right, so here's going to be some interesting geometry. So I'm going to go a standard offset of a 1/10 that way, and come to here that way. And I'm now going to fillet those two 2D polylines with the radius of 0. So this guy and this guy, of course, they're not planar. The that is, select them both. Their elevation is going to be 0. Right now, do the fillet. This guy and this guy would meet as such. Then, if I offset by 0.4, and then all I need to do is to tie these things up here together. So do I want to do it like that? sure. Let's see. If I give myself a target back here. Excuse me, I'm going to extend all three of those. Okay. Now, if I extend this green line, same thing, but for the next one, so that would get these green elevated lines out here. All right, now I'm gonna get rid of these that I used to do that work with. Now, what's going on, and something to consider. In fact, back up here, remember these? We closed off this parking lot, but it would be kind of hard to work on this side, to work in this building if you couldn't drive into the parking lot because it's got curbs all the way around it. That's why that was not there. Also the same thing here. So when you build it, that really needs to go away. However, the line that we're going to use to tell it that this is pavement within here is going to need to be a closed polyline. Okay, so let's actually select that and see if it goes. All right, so it does not go all the way around. It only goes up to there. That's fine. Right, let's get rid of these outer segments. And we're going to join nearest that and that. And then go around to the other side, make sure it's gone all the way around. It has. Okay. Now, if we were to close that, let's take a look at what that looks like. Make sure we didn't have any kind of goof elevation wise. That looks fine. That's exactly what we were after. Okay, now, so the curbs then, if we were to build these actual structured curbs, we would, you know, you could close these things off and build those, you know, as those individual pieces. Now and this would be the way that I would do this in civil, is I would build these structures up and, you know, have each one of those defined. I would maybe drop that down a little bit. Looks like it's flared up from back when we had that little goofy area before. But now, so what I'm trying to point out here is that when we do this, if we consider this one, which is that closed, in fact, I'm going to change the color of it just so you can see it a little bit more distinctly. Let's make it a different color than that. Let's use that color. All right, so because that's going to be a closed polyline, I can tell the system that it not only has everything, you know, it's got certain thickness of asphalt and stone subbase and that sort of stuff, but it is also a curb structure, and I can set the units of the curb up and it can accumulate all that as a linear amount of materials. Okay, so I really did not necessarily have to go through and build these top and back lines, other than I noticed that we did have some of these little drop downs on the back line back here. So, you know, maybe then, you know, we can use this line to accommodate our materials computations. But when we go to actually build this, we would have to use these created lines because we read those differential pieces of text where those curbs have the depression part. And oh, by the way, folks, I have to apologize to you. We've gone about a half hour and 7 minutes or so past our break. So we need to take our break. So we're going to stop for about 15 minutes, give you your full morning break as union scale and all that, actors' wages and such. So we will come back at 25 after the hour, and then we'll maybe push lunch ahead to like 12:30 so we can get a little bit more in this process. So before we do that, though, are there any questions to this point? I mean, does everybody do all this stuff as part of your daily work? And you can, you know, think about that and let me know, you know, what else you're going to do. But it's this layer membership and the material and the thickness that we want to understand how takeoff or the construction module or site net under civil, how it's going to be used to accumulate all this information. And it can actually, you know, create the surfaces quite nicely, but if you need any additional fine tuning like we did yesterday, you can actually define the surface the civil way. You can go ahead and model the surface, you know, pretty tightly, assign that in your list, but then also assign these polylines in to these material designations, all right, and thicknesses. All right, so with that, I'll go ahead and I'll pause our recording. And first of all, I will ask, is everybody else back okay?
Yeah.
Matt,
Yep.
Ryan, Ray,
All good.
okay. And
Yeah, I'm back.
it's like Val's back too. Okay, great. Now, so one thing we've done, we've elevated the curb lines. We're going to use that information. We have that elevation that we're going to use to help to build our design surface. But here is something else that we can do. If you remember, we looked at our defining layers and we had picked, let's look at the design tab. I've got a layer. I'm going to now take this text, that's all of these labels here, and I'm going to move them to other, just so that they will go away when we only just display our design. We won't get cluttered with that. So we put those text over there. Now we've got the pad, which is the building outline. We've got the PRLF and PRFC curb. I don't know which that is. Let me save that and exit. And then I'm going to toggle my design display. I'm going to turn it off and then back on. Oh, I must have moved the wrong text layer. All right, let's see what layers these are. This is PR elevation, PR elevation. Oh, the text was just that building text. All right, so we've got this, which is our proposed face of curb, proposed FC curb. All right, so that's going to be some materials, but here's what we've got. If we look at our layer definition. I'm going to go back to design. There's my my proposed elevation. I'll move that back to other. I've got my pad, I've got my proposed face of curb, and that's good. And I've got this proposed LCST. I'm not sure. Let me save and exit, see if we can find that layer. That should be pad. It is. That should be. There's your PRLCST. I think that stands for proposed landscape, maybe whatever LCST might mean. All right, so there's that. So that now is all our line work is defined. However, we've got these closed polylines, including this one, which is going to determine what materials are going to lie under there. And we also have across the pavement from that line, we've got this line. So that's the catch area, from this line. So everything in between there is going to be asphalt. We've got interruptions with this island right here in the middle. So what we need to do is we're going to define that layer to have that pavement cross-sectional thickness. However, if you remember, these back two pieces of the curb, this top of curb and back of curb, are also on that layer. And I don't need those to define the actual asphalt thickness. So what I would need to do is I'm going to put those on separate layers. We'll keep them in the list of our design, but we're going to just put these on a layer we'll call it PR dash curb dash other. Okay, so I'm going to make a new layer, and I'm going to show you a little trick here. I'm going to make my face of curb layer current. And now when I make a new layer, it's going to inherit those same properties. I'll just give it a name. I'll call it PR dash curb dash other. Okay. And I'm going to now assign these outer structures, making sure that I get them all. So that then walks it around to there. I need to pick it up on this side because we interrupted those out there. So those are not closed, but these are in the middle. That's why I'm putting these on a different layer. And okay, so we're going to put that on layer PR curb other. All right. And now we also need to add those to our design. So I'm going to choose my set layer for design, and I'm going to pick up just one of those to identify the layer. Now, if I go back to my layer list, I see under design, I have PR curb other and PRFC curb. Okay, so now we're going to treat these two things separately. Actually, let me see. I'm going to do one more. Let's save that, exit. I'm going to make, let's go back to my layer list, and that PRFC curb, PR curb other. I need to, let me change this to, let's make that PR. We got the face of curb, so we'll call this TC, the top of curb. And I can take out this. And I'm going to make another new layer called, oops, sorry. Make a new layer and call that BR dash back curb, or BC curb. And that one I'm going to make different colors so we can see it. The face of curb, the top of curb. Let's also make that a, let's give that one blue, just so we can see the differences. Okay, now I'm going to now take the overall backmost. I'll change that color back here in a minute so you can see it better on the screen. So we get all of these backmosts. Making sure I've got all the way around, which I do. Islands, islands. And I'm going to put that on the PRBC back of curb layer. Okay, so now so let's make that top of curb layer a different color. Instead of blue, we'll give it this sort of butterscotch looking color. There we go. So I've got 3 different layers now for this structure, and I'll explain why as we go through this. I'm going back to my layer list again, and under design, I see I've got my pad, my PR face of curb, and there's the landscaping. So I'm going to go to my other tab, and I'm going to find that back of curb and top of curb. So I'll control click that, and I'm going to move those to design. So now I've got all my curb structures, my landscape, my building pad. That's really all I've got. I'll save that and exit. Okay. Now, the reason I did that is I'm going to look at this, which is my face of curb. I can now put that back on, I'll make it that original color so that we now have this face of curb. So we're going to define this closed polyline, and they have to be closed polylines to be able to define a depth structure. Things like that, the building, these landscape areas, that sort of thing. So if we define those areas as a particular material, we're going to do that in our define layer, and we'll go to design, and let's look at the face of curb. Now remember, I told you yesterday you double clicked it and you got that information. Well, it's also right up, it's not here in this one, but if you're running, now Ryan, yours would do this if you're running entrenching, and you do that, or not, sorry, not trenching, but construction, and you go to that takeoff menu, define layer, when you choose that face of curb. Anyway, right down here's this edit layer button that brings that up, same as double clicking. It might actually also be in civil. Let's go back to civil. Define layer, design, we find face of curb. Yeah, down here's this edit layer. So that's the same as double clicking. So if I edit the layer, that brings that up. Okay. So now everything inside of that closed polyline of face of curb Again, you could change its designated target. We're going to include it in the materials report. And if we want to give that a 3D view color, we could set that up to be, let's make it this sort of asphalty looking thing in our view. And the material type is going to simply be area. And if you knew what paving cost you, the entire structure, you could just give it a cost here, per area if you want. But we're going to actually make our depths here. Now there's a couple of things. These area subgrades, and it's going to be top to bottom order. So we're going to go from the top and just work our way down as we put those in. We're going to change our units to inches for our depth. And we can adjust the target surface by this depth. So in other words, that's going to, remember those prefixes or suffixes that we had on the names of the surfaces? So those are going to be those zone adjustments, and you're going to see those when we look at our profiles across the site. And you're going to see those show up as the different depths, and they will accommodate these depths. So let's go ahead and choose these depths. So what is our surface? Let's say we've got 2 inches, or sorry, we'll call this, we'll just keep it asphalt, 2 inches. And again, you can put shrinking factors and all. And if you knew the cost, let's say, does anybody know what you pay for asphalt? You guys are in the business. I have no idea. Or do you even pay for it separately from the stone and everything that goes under it? How would you normally bid this?
Usually we just bid it at per tonnage. So
Okay, so,
cost just you could say like $65 a ton.
all right, so that would be $65. And if you did that by a ton, then you have to specify a density. So how much does asphalt weigh? It's about I don't know. I
It's
know limestone
one.
is
I say 110.
110. Okay. Yeah, because I know the stone is typically that. Now you see these set buttons, you can actually, there's a materials library that you can build up, so then you can keep that going as you work these things. You'll be able to pull those from that library as you assign these. Once you hit OK and save all that, you can start to create that library. All right, now there's one other little aspect here, is that you can either use it vertically from the pad up to the surface, or you can use a layback at a particular slope. Now, where you would do this, for instance, is again, if you're designing like under a building pad, you're putting in basements, you could say, when I excavate that, I'm not going to come vertically up 8 feet. I'm going to have to lay that slope back, and then I'll backfill once I build the building. So that can do that. And it accommodates that laid back amount of material. Okay. So, we're not going to use a layback on that. We're just going to assume that vertical, or if you don't check this on, it's going to give a little bit of layback, just a skosh at the top. So that'll be fine. To keep from having those vertical faces. So we got 2 inches of asphalt on the top. What will we put under that typically? Let's just call it a stone base. I don't know what, 8-inch, 6-inch, what, 12-inch? What would you normally use, and how much does it cost?
Stone base, say 6 inches.
So it's inch stone base, and you pay for that by,
It's usually like 20, yeah, but 20, just say $21 a ton.
all right, so 21 by the ton, and again, that would be like 120 for limestone.
Yeah.
Something like that. All right, anything under the stone?
Geofabric.
Well, you could. And that might even be, just a 1/2 inch, but then you probably buy that by the yard or something.
Yeah, per roll or per yard, but yeah, it's paid per yard, per square yard.
Yeah, so if we did it by the square yard down at the bottom, how much do we buy it for?
Right now it's like gold. Just say 2.25, 2.25.
$2.25 a yard.
Yep.
Okay, and we don't need to set a density there. Obviously, we're just doing the area. All right, so that defines our asphalt pavement, correct?
Yeah.
All right, so we'll say okay. Now, the back of curb line, which around the outside is not a closed polyline, that's okay. All right, we're going to call it a linear feature. And so let's go ahead and define that one. So this back of curb here, and that color, we might, make it on this real light gray, lighter gray. You could even assign a texture to it and, pull up concrete or so. Let's use a cement. Yeah, let's go with this concrete here. Concrete and set your scale and all that kind of stuff. You could do something nice like that. And this is how it shows up in that 3D drive view. So it's now going to be a back of curb or pavement. And let's set in our curb dimensions, and it's going to be this type of curb right here. They're just basically vertical curbs. We're not putting, well, yeah, we're not going to put gutters on there. We didn't accommodate for that out in this other line work. Let's just make them deck curbs. Well, they're not technically deck curbs. And let's put in the dimensions. We'll choose inches and the top, if you can see across there, you got a top and a taper and a drop and a height and all that. So our top is going to be, remember we laid back a 1/10, so that's going to be 5.9, and our taper was 0.1. And then our drop is the amount of drop if we have in this type we've chosen, let's see. Need this. I thought clicking these would do it. It didn't. We had to choose curb type 2. All right, so now the top is 5.9, taper is 0.1. The drop is going to also be that 0.5. And the height one, so I'm going to be, oh, I'm sorry, not 0.5, but 6 inches. And then we had a height of 6 inches. So what is this? What's a 1/10 of a foot in terms of inches? It doesn't have to match exactly. Let's just say it's 1/10. Well, let's say 5 point. Let's make it 5 and 1. Just basically an inch taper on it, because we laid it back a little bit. All right, so that'll match that to that 6, and it'll be 12 inches total depth. And so that makes our base, the base should still be 6. If our top is 5, our taper is 1. Oh, 1, I got a tab out of that. That'll update to 6. There we go. And it's going to be concrete, we'll call it. And how do you pay for your concrete?
Cubic yards.
By cubic yards. All right, so we're going to choose volume cubic yards, and that's, some dollar amount. Give me a number.
196.
196.
Yep.
Okay. And what's it? We don't need the density because we're not paying for it by the ton or anything, but we're doing by the volume. That should be okay. We'll say okay. Now, we don't need this subgrade information here because we've defined it in our curve dimensions here. It's all going to be the material cost is, let's see if we did, we're going to accumulate it based on the length, and it's going to take those dimensions, compute the volume, and so this is if we assigned a cost based simply on the length of curb. We didn't, we assigned it in here as a cost per volume. So that will take care of that, and we'll say okay to that. Now, what about our building pad? So if we edit that, and let's make our building, we'll make it sort of this dusky looking blue. And so this is the actual building pad itself. And that's the building. That would be everything within, underneath that building. And now there's two ways we can approach this thing. You can do that as it follows that building outline. That would be how you would construct that pad. However, the alternative to that would be we're going to, create a building pad that basically takes the outermost edges of that as a pad preparation. Okay. In fact, we'll do that when we get to it. But we've got, we'll try both ways. We'll show you both ways so you can see how it shows up differently. All right, so if we got this pad, we're going to have a concrete slab, right? So concrete. Now, if you called this slab, that would accumulate those costs separately from the concrete of the curb. So because it's got a different name. So you can do it that way. How thick's your typical building pad? You guys have to tell me numbers. I think it's probably like an 8-inch or 6-inch or whatever.
Say 6-inch.
All right, so a 6-inch concrete pad. Again, switching to inches here now for the depth. Make sure you do that. It's easy to forget. I almost did. All right, so it's concrete slab, and we pay for that again by, what was it, $196?
Yeah.
In my cubic yards. And under that was our, stone of how much?
Say 8-inch.
So 8-inch, and that was 2.25, we said, per ton at 120 pounds per cubic foot.
Actually, change it to $21 a ton.
Or 21. What was the 225?
Square yard for geofabric.
Oh, there we go. Thank you. All right, so that defines the pad. And let's do the landscape area here, and we'll give it let's give it a texture of some grass here just for you. And let's see. And it might really may not even really, maybe it's let's see, let's not do that. Let's use a granite, maybe we're using paving stones or whatever. We'll just call these ones granite. say a 4-inch paver, and I don't know, gosh. Get those for $25 a square foot. What would a typical granite countertop cost us? Let's just make it 15. It doesn't matter. You're going to see the numbers.
Yeah.
All right, and then maybe we have some, let's say a sand, but 6 inches.
You
And
gotta change your depth units too from feet to inches.
thank you. I told you it's easy to miss. So, you know, whatever we pay for sand, I don't know, probably buy that by the ton as well. Or how would I pay for sand?
Per ton.
Okay, so per ton and number,
Say 15.
so $15 a ton, and what's its density? I don't know.
Oh, that's a
So-
good question. 100. Yeah, 105 works.
All right. All right, so now we've assigned that for the pad. Now, we'll save that, and we're going to talk about how these things work. Are you familiar with the Tracy? My crosshairs have gotten this little magnifying glass. Let me see if I can. Reset my crosshairs. Let's see, reset crosshairs. Yeah, I think that's, I have to probably save and get back into the drawing. I'm not worried about it. All right, I'm going to save my drawing for the moment here too. Now, so the way this works, are you familiar with hatching? For instance, if I were to hatch this figure, right now, it would hatch edge to edge all the way across everything. But if I turned on what's called island detection, it goes from the outside, works its way to the middle, and as it hits a closed area, it interrupts the hatching. It takes it out of that area and then picks it back up on the other side. So it would hit that. Now we also have this line here is also in there. So it would hatch between those two areas. But these islands then, which are also here and here, would interrupt. And so now that's going to be your paving area there, and they get interrupted by those. There's a couple other things you could do with this. You could make this on these two landscape islands. You could put that on a separate layer and define that as your grass area in between. However, if you turn back on, let me turn back on my other, and I'm going to put my perimeter here back, and I'm going to turn other back off. So if we had this perimeter, and I'm going to now need to take this perimeter and get it out past there. There we go. So if I define this perimeter as everything inside of it being grass, for instance, and let me open this up a little bit outside of that edge. If you were to hatch that as some kind of a grass area, as soon as it hits the next interior island, it will stop it and then pick back up when it runs out. So it will come over here and fill in these areas as grass. but it gets interrupted by the pavement. Okay, so if we simply go to that definition under designer, we've got the perimeter, and now I'm going to define it here in my, let's use that texture as this grass. I'm not going to define any materials here, so it doesn't really matter, you know, what I'm doing with it. You could put some topsoil in there. There's other ways to handle topsoil with your stripping and replacement. All right, so now that should take care of everything by once we build the surface, then we should be able to get those pieces of information. So I'm going to save my drawing, and I'm going to go to my SiteNet, and I've got two things I have to do. Is I have to make an existing ground and a design ground. So I'm going to go ahead and choose make existing ground surface, and it comes up and says, okay, it did it. Now, you're going to, if you take a look at that existing ground, now this is going to be what's their thing called demo 1. So if I look at my demo 1, existing original ground, and this after zone extraction. So that really they all should be the same. So my existing is really what I consider any kind after adjustments. Okay, so that is that I had some issues down in here with some of those crossing contour lines. We didn't really fix it. And here you see there's a sort of a no-no. It's basically got a flat triangle in there. And it had some crossing contour lines in there. So I'm going to go back out and I'm going to look at my settings for a second. Crossing configure. My takeoff settings, I'm going to make sure that I said use flats, minimize flats for existing. Okay, I did that. I'm going to uncheck it for design because I could have some flat areas, and I'll go ahead and keep them as flat. All right, so I'll go back and remake that existing ground. It's done it. I go back and look at it again, and yeah, it didn't really fix that contour that I can see right there, but that's okay. It's sort of a rough and crappy existing ground surface. So next I'm going to make my design surface, and error discarded the perimeter polyline because it's not closed. Okay, so that says it is closed. Why did it? Why did it give me that? Let's run that again, and I'll show you how we can investigate that a little further. So if I make design, all right, so you see this number right here, those at, I'm going to jot that down. Unfortunately, it's 613.5191.5. 219.0335.9. Okay, so that's fine. And there's another one, 135, 191.5. Same. 219.0335. Yeah, same value. All right, so I'm going to find out where that is by drawing a line, just a 2D polyline. I'm going to start it at those locations that it just told me. So 613.5191.5, comma 219.0335.9. Hit enter. So that's right there. Okay. So it's on that one, but that's okay. I don't want that to be closed. Actually, it finishes here. And then this one picks that up. All right, so that's fine. I think there's just some information telling me. And I gave that as a linear figure, but it was not a closed polyline. It doesn't have to be, because we didn't give it depth. We gave it a length around its edge. I think that should be okay. All right. So now we can take a look at that surface, and that's going to be our demo one final. And we can take a look at what we got. So we got this as our building pad, and you can see how it dropped down that thickness. And there's our landscape area, but it did not, and that's why this, that green should have stopped at the edge of the interior asphalt, which was closed. I think it was closed. Is this one closed? Yes, it is. So it took this and it found these two. It should have found all of these others. Let's do this for a second. If we go back to our SiteNet define layer design, I'm going to move that back of curb. Let's see, that was the curb dimensions and all of that. I'm going to try first to take it out of the reporting. So it's not being reported. I'll leave it in there. Let's save and go back to make that surface again, which is also these buttons here. There's existing, there's design. So I'll make design again. I should get the same message. Yeah. Discarded a perimeter polyline. It's okay. If I look at my surface again, of course, it's going to give me that. Let's look at demo one. Let's look at the base surface. Yeah, it's still the same. But you don't see the depth because that's just the base. If we look at the final, then that's going to give us that depth. So that's basically my subgrade. And you can see it did accommodate the curb structure. But it kept pushing this across. That's, it should have been interrupted by this right here, which is a closed polyline, and then these other ones. Is this one also closed? It is, yes. All right, so if we take out this back of curb for a minute. Let's put it into other. And now rebuild. Now, when we look at the final, it's still not picking it up. Let's try our 3D drive. Yeah, why not? Okay, pick the starting position. That's fine. Yeah, see, it didn't. I mean, you got the grass in between, but why is the asphalt not? Doing it? That is closed. That is closed. That's not working unless this is crossing at some point. I don't think so. Let's take it out a little bit further. Maybe there's some tight locations, which really shouldn't matter. It's all mathematical. Everything is outside. No. All right, let's come back to this. I'm going to take my proposed back of curb and put it back in design. If I do that back of curb, I will include it. It is a curb with those dimensions. So it's nice to know that that kept those definitions. Now, I'm going to do something here. I'm going to make this my current layer, and I'm going to draw a 3D line. I'm going to start right here and accept that elevation. I'm going to walk around to here. I'm going to interpolate. Accept that elevation. So that closed that. I'm going to go over here and do the same thing. No need to prompt. I'll start here and go to here. Okay, and now I'm going to join here and here and here. Make sure I'm all the way around my feature. I am. Let's also get that, and we'll say okay. And now we look at that. It is indeed closed. Let's see what happens with that. And that should not have given us a problem, but I didn't see the error this time. And if I look at, there we go, that's what I was looking for. So for whatever reason, that back line had to be closed off. And so you can see the asphalt pavement. I'm looking at the final, so that's digging down as deep as I need to go down into that subgrade, and that's where I start to, put in the stone and the asphalt. There's that building pad, again, the same thing with that. My landscape area, see, that's where that green should have gotten interrupted by the landscaping. Apparently decided not to. To make sure that one's closed. It is. Well, what do we do about that just in terms of the materials, unless did we, let's see here, was there, did we give that a color? Gave it a texture of granite. Okay, it worked earlier. So if we view the top surface, which would be my demo one base, and it's still missing that. Well, it does at least give us the depth. It cuts it out for the material. It just doesn't color it correctly. All right, so let's let that go at the moment. And so now we've done our build. Let's look at the total volume. So I'm going to choose that one. And it says, do you need to update? Just in case it really didn't need to update. So now I can put shrink and swell factors, nothing that I'm going to worry about with that. I can report tonnage if I want, or depth zones. I don't have any kind of really depth to worry about. And then you can even have it balance the cut and the fill and tell you what it's going to do. If I say balance cut and fill, so it's going to tell us what I need to do. So here's a balance cut and fill. It adjusted the design surface by 1.331 feet. So it raised it up so that it would make it into a balanced surface. Okay, so that's just in computing those volumes. Do I want to save the adjusted? I'm going to say no, because, I'm going to be constrained more with what the design calls for than whether it's balanced or not. But in case you're in a case where you can set them in wherever you need to make them balanced, you can do that. So if I look at my material, that was my total volumes. Here's my material quantities. We're going to look at a detailed report for the entire drawing. We'll limit the quantities by the boundary. We'll do a report by material. We'll subtotal the quantities, report tonnage, report cost, and say okay. And so it's going to read everything there. We're going to now build our report. We need the material. We can look at the length, the area, if we had any there we were curious about. We've got a depth. Do subgrades, and there's your concrete slab. An area in square yards, and volume in cubic yards, cost. There's our granite. Maybe we can get an idea of why it's not coloring correctly. asphalt in square yards as well. Geofabric. All right, then let's just look at that as a columnar report. Length, area depth, subgrade, etc. We exit that and look at it in a spreadsheet, and then you can output that to Excel. Let's see if we can get these columns to be the right width. Six-inch concrete slab. Here's my area, and here's my cost. All right, so that's basically just that as that report viewer. If I repeat that same materials report, this time let's just look at a summary report and say, okay, do I have to build this report again? Let's see, maybe, all right, that one's pre-built. Do it HTML. So here's my breakout quantities. I've got my pad, my depth, my costs for each of these materials to build this little site. Let's see, what else do we want to look at? Report viewer. That would typically be sort of a multi-page interactive. You can, if there's only one page, but you can see you can scroll through that. That's similar to what you just looked at before. So different ways of looking at this. Again, put it in your spreadsheet. You can export it to Excel, do all of those kind of things with it. Let's look at it one more time as a detailed report, and yeah, this is a material. So here's so far we had basically $250,000 to prep that site. Is that within the realm of reasonable for your all's experience?
Val would know best.
What was that?
I said Val would know better than
Oh, yeah.
than me.
So, to prep that up, it's giving me that as a total material cost sorry, I got to get back to Travis here in a minute. So
I'd say that seems reasonable for how big the site is.
all right. And there's I'm disappointed that landscape area, once we fix the curbing stuff, and then of course we can, do this. You can change the vehicle, and let's see, if you're looking at this and you run this and use the arrows on the keyboard to change this around, you can get an idea as, I want to slow this down a little bit. Let's see. Where's my speed here? There we go. So you can see, as the bulldozer rocks, you can, if you watch this now, you can see these slopes and roll values, see how they trigger as you're going up. So that doesn't make a lot of sense in this flat site when you're just doing this, but if you're on like a a graded embankment or something, you can get a sense of how that looks. All right, so it's just another way of looking at the surface. So a couple other things that you can do here real quick, and we'll stop for lunch at 12:30. If you look at, we've got these other areas of interest. So what we can do is if we draw some polylines, just a 2D polyline, and I'm going to put this on a layer called AOI for area of interest. And we'll make it, oh, just bright yellow, it'll be fine. And I'm going to say, I'm going to start right here, say right in there. And I'm going to basically split the site in the middle up to right here. And then I'm going to follow this guy.
Send you a copy over that. I know we talked about it earlier, but
Start there, and I'm going to come out of it right here. And yes, that's the correct place. And then I'm going to come down to this corner. And I could choose to follow all the way around. I'm not going to. I'm just going to go outside of it here too and just come here and say,
hello. Oh, happy Friday. What's going on?
all right, so now I've created this as my, maybe this is my phase one. And then maybe I'm going to draw another one here. And I'll just say go from here out here, and let's just call that, and I'll follow this guy from here all the way around. Let's see, no interpolation, all the way around to here. And is that the correct one? Yes, it is. Let's see, I didn't mean that to happen. I got that. Oh. Didn't look right. All right, so I'll go from here. Now I'm going to follow this guy from here. And I'm going to follow him all the way around to here. And it says, is that correct? I'll say, no, that's the correct one. There we go. Did say yes. Done. So now I've got two closed polylines. And I'm going to label these now with my area of interest. I'm going to tag. So this one I'll tag here. And I'm going to call that one phase one. No exclusions. I'll repeat the command and do this one and call it phase two. That's fine. And no. All right. So now when you repeat this material quantities, we'll say, we'll just look at a summary report and we'll say, okay, we should see our phase area here. All right, we didn't I did not break that out. Well, let me try this again here. Line material quantities, standard report. All right, that's good. All right, so my areas of interest. Identify areas of interest. It's like this. Now, if I choose this one, it identifies them. Okay, they're named. Report hatch. So that's both of those. All right. Now, if I rebuild existing and rebuild design, I should see this split out by, there we go. So now I had to rebuild the surface and you saw it identify those. So, oh, I also told it to balance. I didn't mean to do that, but here's my areas of interest. So within phase one, I have this amount of cut and fill and et cetera, et cetera. Same thing for phase two, and I'm not gonna save the design. Let's repeat the command, except this time I'm not gonna balance it. All right, so now you can see it identifies the two areas. And I do see one thing that I've got one that goes that way around. This one goes, okay, so it included that phase one includes that entire area. I meant to go around this direction, but that's okay. You can see how it's worked with those two different phases. And then if I do the my volumes, my material quantities, again, it should pick those out by phasing. I don't see that happening. So
Hey Ken, on that previous screen you had, it had a wherever um it said something like to include areas of interest and it was unchecked. Does that matter at all?
did I blow right past? I didn't mean to do that. Let's see, right here. Ah, use areas of interest. Good heavens. Thanks for being smarter than the teacher here. I like that.
Every once in a while blind squirrel finds a nut.
That's right. All right. So, but now it's not, I'm not seeing here. I think all it does is if I display that, it should then, it's still not breaking that out by area of interest. I don't see. Breakout quantity, needle paths down. Subtotal.
It looks like it does break it out. It's just the format's just weird that it's like there's no subtotal per phase. And it could be the way the thing's written too.
Yeah, but see, I don't have a phase here. If I choose grand total material length and all that, so grand total material, include totals, grand material. Yeah. Let's choose that. Again, those are my materials. This is my volume materials. Let's see if I by boundary. Yeah, it should work, but it didn't give me my, oh, I'm sorry, area name. I was looking for phase, but instead, let's see, let's do that. Grand total and area. Let's come down here at the bottom. And so we're going to look at a grand total material. Should be still okay. I got my area name. Now let's look and see if that happened. Worry about the format another day. It's only totaling material length, material length, material length, material length, material length. So got the area thing. Let's move it up. See if that gave us any. All right, here we go. Breakout quantities, phase one. Breakout quantities for phase two. Subtotals. And then here's my totals. Area name and the grand totals at the bottom. So I just needed to move that up to the top. So that now splits those by those areas of interest. And you can use that for bidding purposes or what have you. Now, real quickly to show you how those different depths and adjustments are going to go, is there's a tool right here called Quick Profile. It's also available under the Profiles menu. You got a Quick Profile here, but under the SiteNet Quick Profile, you get a little difference. If you look at Quick Profile under Civil, let's just use a surface file. We're going to have the first surface will be our demo. Let's do our final, and our second will be the original ground. I'll say okay, and then if we just say pick a point here, go across, you're going to see this, and you see the white indication. Now I'm exaggerated here. There's my, at 1:1, you can see as I track, I'm just going to click up here and zoom in a little bit so you can see as we go around. Like so, we're tracking across the site just for those two things. Now that's the civil one. We're just looking at the two surfaces. Now, if you choose it from SiteNet and do a quick profile, you're going to get a little bit of a difference. You're going to do it the same way. We're going to just pick a starting point. Let's just say start here and go across the site. And I know I'll pick another point, just the one. So I'm going to look across the site. Now you see the different surfaces. You can see over here, I'm looking at the original ground. If I had any topsoil removal, you'd see that show up that sort of parallels that original ground, which you can see in the white line. Let's go back. Let's just make that a 2x. Let's see, I don't want to get it too vertically separated so we can see it. I can't really, let's keep it as a 5. And then if I've got any adjusted subgrades down here, you would see that show up separately. So right now it's looking at the original ground, which is the white, the design surface, which is the topmost yellow, and the final target is that depth. That's my subgrade prep that I would have to do the excavation on. Okay. And then you can do this adjust alignment and watch what happens. If I just pick near the midpoint, as I move this around, you're actually looking at it in real time. It's cutting through all that stuff in real time as we go. I can plop it down again, and then I can adjust and pick nearer to the end point. And unfortunately, you have to keep doing it, point by point. So if we want to look across the site this way, and now we can take it, and just move it, just get a nice little sliding view of the prep across the site as well. Okay. And you can even, let's say, put that, say, right in, let's go across the curb island here a little bit. And come out across the back edges here. So that would go right through the parking lot. You see the curb on the outside, the raised island in the middle, and out to the other side. And you can even, draw that into your drawing as I'm just going to take the defaults, but these are all controllable. You can set the vertical scale and give it the, the different colors and line weights and that sort of stuff. Make sure I'm viewing my line weight, so you can actually, draw this stuff and freeze on and off the grids and what have you. And you define what it's going to show you. See here, it's showing the original ground, the finished ground, and the amount of cut. And at some point, that might switch to fill. Yeah, they were in fill over here. Okay. So just another means of help to evaluate your models. Okay, so I'm going to say that we need to take our lunch break here, folks. It's 1:45. I'm sorry it's so late getting to it. But we'll look at a couple of other things that we can do with it. And when we come back, I'd like to spend a little bit of time. Are you guys familiar with running RoadNet and doing the road design stuff? Or does anybody?
I've seen it before. There was a surveyor over at Trumbull like a year ago, like taught a quick class in it with like
Okay.
running the super elevation table and stuff.
Yeah, but I mean, I wouldn't even get into that so much as, we just need to define a center line and profile and a cross-sectional template and then show you how the reports will accumulate those materials as well.
Oh yeah, he didn't get into like the materials. This was more for like building a surface and stuff.
Oh, okay. All right, so we'll run through that as a quick little exercise so you can see that, if I were doing a road, I would do it in that fashion. Now, again, you're not going to be designing a road. You're going to be, probably typing into the road editors the values that the engineers have done in their plans for the road. But I'll show you that process so that you can get a sense of maybe that's a little better tool than using this from the site net and the takeoff kind of approach. But at this stage, you've got this information. Now we've also got, something. I wouldn't go out there and build this because I don't want to build that curbway across here. But I would take, that outermost edge and project it out to the existing ground using design pad template to get my, final tie-in out here on these edges so I could know exactly how to build that material. And then once I did that and I got that, I might adjust the boundary to be that daylight line wherever it hits out there on the ground, and then rebuild these surfaces if I wanted to account for the materials out in here for the tie-in. Okay, so right now, just in this little exercise, and the whole thing was meant to show you some of the various tools on how to elevate different things. There's one that we didn't do yet for the pad. This building, now we wouldn't go out there and make this building pad exactly the outline of that building. So you've got, you know, a tool on this under 3D data where you can draw the building envelope polyline. And we'll put that on a layer called building pad, and you might make it, oh, let's just make it 5 feet offset. And you could prompt for each side. I'm not going to prompt for that. I'm just going to say, okay, and I'll choose my building. And that would be the pad that you would build. Now, obviously, you wouldn't build it all the way out here into the parking lot, you know. So, you know, maybe you'd make it, you know, a foot offset or maybe even 0 offset. Draw another, let's say yes. Well, it's going to use the same value. So I'm going to erase that one and then do that one again. This time I'm going to make it, let's just give it a foot offset. And so that would be, you know, maybe what I would build for the building pad. And then I would build this building around it. Now, see, it did not step me back in here. So you could do that just by, you know, offsetting this a foot and a foot and then breaking this out and trimming this up. And then because this is now on this layer called, what do we call it? Building pad, you would go back into your layer definitions from the other, find that building pad, move that to your design, and then maybe pad, you would, you know, move that back to other because you're going to prep that pad all the way down through. You know, so that's just, we're not going to say that kind of stuff, but those are some of the things that you can do for this stuff to really reflect more the way you would go out and build it. Like, you know, would you build this landscape area? Maybe you would follow that outline because you know, it's not that big and you're just digging down to put some pavers in. But I don't know anybody that would really put a slab, and you guys tell me if I'm incorrect here. I'm assuming that it would be more difficult to try to construct a pad that looked like this, a slab, than it would to, you know, find out what, you know, and maybe not quite so far away, but maybe you would generalize the pad that sits under the building. What would you guys normally do?
It depends. Usually, it depends upon what the contractor wants to do for that, and like even just for the sub in that regard. But for most site work we've done,
Mhm.
usually it's a rectangle, like you
Right.
have drawn there, and then they just kind of, surveyors will give them offsets.
Yeah. But like, and so you might prep the pad, you might grade the pad down to there, but maybe not put the slab all the way out to those edges. Is that, you know, maybe only put the slab to more follow the building foundations? I don't know. Anyway, you can see the types of adjustments that you can make on these things. And it just, like you said, depends on what the owner or the contractor might want to do. Okay. So with that, let's stop and take our lunch break. We'll come back at 10 till 2, and then we'll look at some of the road design stuff as we follow that. We're not really, I was going to run you maybe through the trenching stuff, but since you guys don't have the takeoff product, that's really just like the grading like we did yesterday with the little ditch down through that area. We set them at a slope. We set the bottom width and we came out of the sides. You know, we built our trench sort of piecemeal, which is perfectly fine to do. We don't need to have those done in that fashion. So with that, let's pause our recordings. A couple of things that we wanted to look at. We're going to look at a couple of road tools, but these guys here from Plum had we're talking about how they sometimes use cross sections to do some of that work, which is fine too. I'm gonna go ahead and turn you guys' videos off. Just give me a little more bandwidth. There we go. And so one of the things, like, we've got these different surfaces, and here's something. If you wanted to take a look at the let's say a cross section across our site, I'm going to just draw a line here. I'm going to put it on say C dash X SEC dash CL. So a proposed cross section center line, and we'll do it by color or by layer. Let's say okay, and I'm going to go from here, and I'm going to just put this at perpendicular to say one of my building walls. Then I'll drag this out and I'll keep the projection. If I can get it to read, there we go. No. Come on. There we go. So keep that extension. I lost it again. Ah. Oh, well, it doesn't matter. Just put it there. All right. So if I've got, say, this, I'm going to set it up as the center of my cross sections. And this is in our civil menus under the sections, where you can set up, you can do this section alignment editor. And if I choose that, I'm going to make a new section file. I'll just call it, I'll just keep the same demo one. And I'm going to use either a centerline file or select the polyline, which is my default. So I'll choose the polyline. Beginning of the alignment, I'll call it 0. And now I'm going to do my station interval. Let's go every 10 feet on this small site. And we'll go a left offset of, oh, I don't know, probably 50 feet's sufficient. I didn't measure that ahead of time. We'll just make them 75. We use roadway curves that don't have any curves in my alignment. It's just a straight thing here. Oh, here we go. If I pick the offset distances, that'll let me do that. And station interval stations at special stations, any of these kind of different things, as if I were doing a roadway. But I'm just going to use this to do this. So I'm going to say, okay, so my right offset distance, I can actually show it from here to make sure I'm out far enough away to incorporate that edge. My left offset distance, I'll take from here and go. That should be sufficient there. Okay, so now I've got these that it created. Give me a station 5, whatever that one is. If I edit, no idea. I guess that's the, or so 0 to 550, and then it goes all the way out to the end point. And you can see here, so I can really, you know, cut it back a few of these. So you're going to run out of information. And I really didn't get this back corner. So let me exit that and not save those changes, and then just do a redraw. I'm going to pull this back enough. And again, I can't get the extension to work correctly. I'll get enough to accommodate that. And we'll try that one more time. We're going to do this new demo 1, open. We'll choose that alignment, start with 0. We'll pick the offsets. We'll say every 10 feet. And we're going to go from here far enough to get past that edge. And then we're going to go from here far enough to get past that edge. There we go. So now we'll cover everything. Some of those will be empty. So we'll say save. And then exit that. And if you just do a redraw, just change your zoom level. All those were just markers to show you where they were. So now, if you come down here and look at your section file, where we're going to create sections, first of all, from triangulation surfaces, from polylines, from these different areas, we're going to section points from the, I don't know if this surface entities, I'm not sure that's going to work. Let me see. We'll process that file. Section file to write. We'll call this from surface entities. And let's see, section interpolate. That's fine. Extrapolate endpoint elevation. None of that I need to worry about. Interpolate from the surface data beyond the limit. Let's cut off at the end of the surface data. Ignore zeros. And let's see, let's do that. And select the things that define the surfaces. So that would be all of these elevated lines. And then if I look at that, I'll do my section file edit. I'm going to edit my section file, this one from the surface entities. Here they are. And you can step through them, you know, as you go back and forth. Let's see, let me make this a little bit bigger here. What I want to do is center all that. So as I work my way across the site, now there should be a little marker. I'm not sure that marker is going to show up there. It doesn't really. It just, as I step through all of those cross sections that are done, you can see what it's doing there as well. So that is by looking at those elevated items that went into making those surfaces, but it's not actually reading the surface data itself. So if we close that off, and here's another thing you can do. Let's say you needed a section at 1 plus 25. Well, you can actually interpolate in between. So a single station will say 125 and interpolate that. And I don't have a profile. User F, there we go, uncheck that. And don't need that either. So just interpolate that. We'll exit that. Now I've got a 1 plus 25. And you can see it actually read the 1 plus 20, the 1 plus 30, and sort of found the average difference between the two and gave that as an interpolation. Okay, now notice in here, remember these points and the layers and stuff that we put them on? So there's the face of curb, top of curb, back of curb kind of thing. So that gives you, you know, what the elevations are and what the offsets from that center line is. So in fact, maybe if you were, you know, staking this out, you could, you know, put a baseline across the site and you could actually stake the whole site out from that. It's probably not the most efficient way, but you could do that. If I add the subgrades, I'm not really, I want to be able to pull that from the surface. It's not, this would be where I would actually type in depths if I knew those subgrades. So this is a way of constructing your subgrade in that particular section file. Now I'm going to switch out of that and let's go back to sections, and now that's my section alignment. I'm going to now create sections from my grid or triangulation surface. So if I do this one, I'm going to make one called, you see this up here, the demo one OG FN. So I'm going to take, now that OG, that's the original ground. Okay, so I'm going to open that up and link sections to the triangulation. If you did this linking, then if the triangulation changed, it would automatically update the section file. Right now, I'm not going to change anything, so I'm just going to leave them off, so it's not going to have to process it. And the alignment file is that one. So that's going to be my original ground. And I'm going to write that now as, let's say EG-ORIG. So that's now my existing ground. Now, I'll repeat that command, and the grid or triangulation file I want to process. I don't need any more of those existings because I did not do any topsoil removal and stripping. That's just going to be my base reference. So I'm going to look at my demo one base. Okay, that's the unadjusted top surface. And I'm going to call that one my final grade top. Oh, sorry. It looks asking me for, I got to read what it's asking me for now. Let's see, FG-top. That'll be fine. All right, so we did that one. I'm going to repeat it one more time, and this time I'm going to use the demo one FN, and this is the actual subgrade. So I'm going to take that alignment, same alignment, and I'm going to call it FG-subgrade. Okay, so now I have 3 different section files, and I can look at those in my section file editor. I'm going to open up my subgrade. Let's see, where is my FG? Here's my subgrade. And I'm going to come down here and do a reference section. I'm going to add in the EG original. So now I've got those two. And if I start stepping through, there you can see the original ground is that red line, and the subgrade is the one that I'm editing now. And you can then, step this through the different ones. Okay. And you can't really, with this editor, I don't have a way to necessarily, indicate cuts and fills and all that at particular points, but you've got all this stuff in your section file. Okay. And then if you wanted to look at, instead of, or there's a section grade, let's find a station that's 2 + 0, 0. And let's look at the 0 offset. Value. So let me run this down here till I see. And there's not really a, see, there's that one goes to the left and it goes all the way to the right. Let's choose the first one to the right. That's at 27, and you see the elevation is 814.9, or it has a depth of 2.6 feet. So if I, let me jot those down. I'm at offset 27.1. Depth equals 2.61. So now looking at that, let's see. Oh, the other thing you can do, instead of just dragging this around, you can actually hit the drive button and set up a particular speed. That's a little bit fast. Let's go 25. and focus view on the offset range of, let's say, 150. To 100. So now as I'm doing that, it's stepping through all of those sections. Okay, driving at that speed through that section file. Now I've got, the same thing as if I'm driving it. Okay, so now to compare that to the subgrade up here, I'm going to now, instead of using subgrade, I'm going to use the top. And I'm going to find it at station 2. And I'm going to scroll down here and find that offset of 27.1. And you see my depth now is 1.899. So that's the top. So you saw the subgrade actually showed you that as a section. Okay. And you can plot these, draw them, superimpose them one over top of the other. What else can we do under sections here? You can actually, let's see. These are just quick sections now. You can do a report, offset and elevation reporting, cut fill analysis based on that. You can actually redesign your, if you have to do any regrading based on the section editors. And sometimes, and you can see you can do, mass hauled diagrams and the whole bit if you're doing like long roadway alignments. And you can add these information like pipes and such like that you can add into them. You can overlay a section file. So if you overlay, let's see, my existing would be this original. My proposed would be the top. Oh, no, let's see, my existing is here. My proposed, I don't think that's asking for a pavement overlay. Let me see. Yeah, it is. Overlay value or a proposed elevation. All right, so that's not exactly what I thought it was. I was trying to figure out a way to bring these into the editor more than one file at a time. I think the only thing I can do is that, one file at a time and switch those. I can then draw them on top of each other to do it that way. Now the roadway processor, because it's got defined subgrades in the roadway data, when it generates these cross sections, it actually puts those subgrade components in each of those cross sections. If I do this from, excuse me, if I do this from, you can do it from, let's see, layers, from 3D. If I'd drawn those components in as 3D solids, it would pick those up as well. So, and get, points from any pipes that you might have under the ground. So various numbers of ways that you can use those section files to help you look at those. If I look, section area. I can merge, I can compare. Let's compare the subgrade to the top. Yeah, it's just a report. So it basically gives me the elevation and the elevation at each of those same stations and offset. It's just a point by point comparison. So, you know, a couple of ways that you can help to evaluate this stuff, just like that quick profile on the SiteNet menu basically shows you. In this case, it would be, you know, a profile along, and if I wanted to look at those as sections, I would have to do them at those little drawn cross-sectional lines that I did every 10 feet. And then if you draw the section, let's see, if you do a section report, can I get the volume out? I don't think so. My subgrade. Yeah, that's just going, I can set a reference center line. Elevation differences. Yeah, that would be if I had a profile to go with it. The elevation difference is going to be from offset point to offset point. So let's look at it with another section file. That's much like we did before. And then the reference section file would be my top. And starting station, that's fine. Yeah, so you get that, and maybe a delta Z if you wanted to put that in there as well. All right, so there's your individual. At these stations, you're comparing the subgrade to the top. So there's your stations and offset, there's your elevation, and then the deltas, in which case you can see that going down. It's much like a cut and fill kind of demonstration. You see these are all the same 0.708, 708, 708. That's that, you know, whatever number of inches that is to where we cut down to the subgrade. Okay. So, you know, explore some of those options there with some other ways of evaluating this information. You'll be able to see, you know, some possibly some benefits out of those. You can basically put that, and again, pulls from the sections menu, and it's not really part of our takeoff business, but we can create those, you know, just based on those individual different surfaces. Now, if we, one other thing that we might do is, let's see, let's look at this subgrade surface, for instance, which was my final. And this is my viewer for that. Now, I'm going to go over to my model tab, and I'm going to add a surface, and I'm going to add the top grade, which is this BS, and I'm going to also add the existing grade, which was my OG. All right, so I've got 3 different surfaces loaded, and I can just double click each of these. If I want to turn off the top grade, I'll just double click it, turn that off, turn off the existing. You can right click and choose the properties, and you can set an opacity level so you can see through them, set a color, or set you know, so there's the opacity, there's the existing ground. If I want to look at the let's see, there's the top, and I'll turn off the subgrade. So now you can see right in here in the building pad area. And if I look at, if I turn that one back off and then, oops, turn that one back off, and there's my cut down to my subgrade. Okay, so a lot of things that you can do inside of this just standard 3D surface viewer, and you just, on this model tab, you've got all kinds of additional controls that you can start adding into this as well. Okay. What was the other? There was one other. Let's see, base, existing final, OGZ, EZN. Let me see that one here for a second. That's if I had any particular like over excavation zone type adjustments to it, which I don't really have. Let's go back to this and make sure we've got our opacity set back all the way up. There we go. Sort of losing track of some of the coloration on some of those, which is fine. All right, so, you know, explore some of those options there over on those other tabs. It might give you a good sense of being able to look at this. You've also got, and this is, you know, they tout this pretty heavily in all the takeoff training and stuff. You've got that drive simulation, so you could drive a site and make sure your grades are looking good. And you've got, you know, you can choose a different vehicle, whether it's going to be shaded or not, colors, different models. You can add these, you know, different. All right, so let's say the boss is coming out in a Blazer. And let's see, let's set that to our view control instead of the dozer. We might have used that Blazer instead. Let me select assemble. I don't. There, did I not? Okay. So now you see I've got a little different guy, and I can have him, you know, driving across it. It's really sort of cutesy pie, but it can also give you some insights. Like you can see, and especially if you're rocking the car around, or if you're changing your view position to like the driver, and then you can look out the front or look out the left window, you know, all these different kinds of controls that you've got. Now it's small side, I'm running on and off. Okay. So, you know, that's another way of visualizing to make sure you've got everything done correctly. Now, let's put this away, and we're going to go through that little design pad example with that borrow pit where we can do a targeted balance. So I'm going to close that file. And I'm going to open. I'm going to have to find which one this one might be. I think it is example 1. Yeah, here we go. All right, so this is basically just a bunch of points. And now part of the exercise that we use this for, and it's in your book, if you go back to this manual, the civil design manual, and if you look at the exercise, and this is in the, before you get into the actual road design stuff, in this exercise, we're looking at this putting it all together workflow. So there's these points. Now it steps you through creating Carlson points from that, and how to, you know, we go over that pretty heavily in the fundamentals part of things, but we're going to basically design us a little borrow pit in this file is what we'll do. So instead of going through all the exercises to do that, I'm going to do this pretty quickly for you. I'm going to shrink wrap this data. I'm going to go ahead and just draw the shrink wrap. I'm going to make it a 3D, go across gaps, and let's do just a medium reduction. We'll say okay, and let's see what happens. So that goes around, connects all our toe points. We may have something to change. Here's one we might want to get rid of that particular vertex. I'm going to get rid of that one. Toe to toe to toe to toe, toe to toe, 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 toe. Here's another one to get rid of. Toe, toe, and close. Okay, so that's fine. So that's now going to be, I'm going to use that to create the bottom of my stockpile. So I'm just going to do a triangulate and contour. I'm going to write a file, and I'm going to call that SP for stockpile base. I use inclusion and exclusion areas because I've got the boundary drawn. Write the file. I'm not going to triangulate this at all. I'll make sure nothing's on my selection tab. I'm going to densify my break lines. Every 10 feet will be fine. And none of these adjustments, I'll just say okay. It now says pick the inclusion parameter, which is that. No exclusions. And now the points and things to break. There's a 3D line right there, and that's the only thing I'm going to use. So now that's going to be that stockpile base. And you could see it's essentially the bottom, it followed and it went edge to edge. You can see the triangles. I just turn this off. You can see how they went across. Now, that's, probably should have laid in some other work in it, but this will be sufficient for us to get some numbers. All right. So now we're going to compute the actual surface itself. So I'm going to triangulate and contour again. And I'm going to create this SP-top, stockpile top. And again, that's all I'll do. I'm going to take this as my inclusion, no exclusions, and I'm going to grab everything. So it's going to actually match up exactly around the base. I'm going to look at this now for my top surface. And you can see it includes those points in the middle that give it some definition. So this is basically a stone stockpile. And I'm going to now just erase. I'm going to grab everything. Maybe I will now shift select that one. I'm going to just erase those points. All right. So I've kept the boundary just because I want to see it. I don't even really, well, let's get rid of that one too. You can put that back from your surface menu at the bottom where you draw surface. You can draw the actual surface boundary. Make it as a 3D if you'd like. Say okay, there's my top. And that just basically reproduced that boundary for us if you needed it for any particular reason. You can also, under surface, now I'm going to draw the contours. I'm going to contour from a 10 file. And the contours I'm going to draw are my SP top. And I'm going to, I don't need to use the inclusion exclusion anymore because it's going to stop at the edge of the surface anyway. I'm going to draw the contours, and this time I'm going to change these layer names to V instead of C dash because it's survey that's existing. So I'm gonna say, let's go 1s and 5s, no smoothing. And let's label the index only. Down here, we label index only, align with the contour, draw where it is, and hide the drawing under the label. And we'll just do a distance interval of every, say, 150 feet. We'll say okay. And there they are, and there's the labels. Now, what you can do with the labels is, well, one thing I want to do is I'm going to go to my drawing setup, and instead of being a 50 scale, let's make that a 20 scale. Set my line type there, and I'm going to now repeat that command. Get rid of those, and let's just draw those again at a different scale. So let's contour from 10, use that file, leave everything as it was, say okay. And there they are with a little bit smaller labels. Let's try that one more time and get them not quite so many on there. So let's go to the top, and let's go over here and make sure we are erasing those previous ones. And let's go down here to the labeling, and this time, I don't know why it reset it to 60, but we'll put it back to, let's say 200 even. And we'll say, okay. There we go. Now there's just basically a few. So once these are done, you see this one here sort of hanging out at the corner. You've got a tool under surface where you can modify the contours. You can move the, or not modify the contours, but the contour labels. You can move the label along the contour, and you just pick that, and it's going to walk the contour, and it will, reorient itself if it needs to. So let's get this off the back side and bring it over here, say, it'll reorient its rotation if it needs to. All right, so those are probably sufficient for what we need. So those are there. I'm going to, just because my anal retentive nature, I've got these two layers. I'm going to change the line type. I want to add in, so I'm going to load, and I'm going to scroll down, and I'm looking for a contour line, or a line type that is named contour. It happens to be here. It's in that iCAD line type file. So I'm just going to add these two. Hang on. This one and this one, and I want to bring some centerline files in here too. So I'm going to control click those, because I could do a roadway if I needed that. So I'm going to load all those up. And now for my index ones, I'm going to use my contour 2. For my intermediates, I'm going to use contour 2 for the intermediates. The index ones, I want contour, the bigger one. So I've got those. I'll change the color. Now for my index ones will be this 253. My intermediates, I'll make this a little bit darker, 252, maybe 251. And I'll give these some visible line weights. I'll come down here and make sure my line weights are displayed on. And I'm going to make sure my LT scale is set. Oops, MS LT scale. I'm going to turn that on, and then I'm going to regen all. Okay, I'm going to select these two, right click, select similar, make sure that my line type generation is turned on. It is. Okay, so fine. I'll set my MSLT scale should be on. It is. Anyway, you can see the dash patterns. I was trying to get that a little bigger pattern. I could change the individual line type scale, but that's fine. That's going to be our existing ground, okay? Now, let's design our borrow pit. So I'm going to just draw a 2D polyline here. And I'm going to put it on this layer called C dash site dash borrow, we'll call it. And it's going to build that layer for me. So it now says, where do you want to draw? Well, I'm going to say, I'm going to go from here to here, you know, maybe around like this, and maybe back here to the backside, maybe up here a little bit, and then close. So that's now going to be the bottom of my borrow pit, and I'm going to use design pad template to put that into place. So I'm going to go to my surface, design pad template. Everything is all good to go here. I would say, okay, I would choose my outline. Now remember, it's at 0, but what am I going to target? I'm going for that top surface. And it wants, oh, sorry, it's left over from when I was doing this targeting a template. I'm going to use just a ratio slope. There we go. I'm going to the outside, so I'm going to choose this, choose my target surface, and let's just go with, say, 3:1 side slopes. And now it wants to know an elevation, and it says the range of existing ground elevations along the pad go from 395 to 403, 395.80 to 403.37, and it offers to use the lowest point. Well, let's say maybe we're going to put that down at, say, 391. Okay, just about 4.5 feet below the ground at the lowest point. So now that would work, and it ran that off the surface because it was too deep for 3:1. So I'm going to redesign that. Instead of using 3:1s, I'm going to use 2:1s. Let's see if that gets me back a little better. We'll keep that there. And no. And it still gave me a little bit off the surface. So that's fine. I'm going to say, no, I'm not going to redesign it here with that one, but I'm going to go to my surface and edit pad template. And when I do this one, there's my 2:1 side slopes, my elevation. I'm going to move the pad down the hill a little bit. So I'm going to go from here and just bring it a little bit further to the interior. And then I'm going to choose process, and it's going to recompute. Now everything fits. All right. So there it is. And I see that I've got 3,070.3 cubic yards up here reporting me that's the amount of cut that I have in this borrow pit. So let's say if I need, instead of 3,000 yards, maybe I need 2,000 yards out of this borrow pit. So I'm going to choose my balance, and I want to take out 2,000 yards of material. So that's going to be my balance condition. I'm going to say okay, and it's going to readjust the elevation. It raised it up to 393.6. I no longer had to dig it down to 391. Okay. And you could do your reports and all that kind of stuff. And there you can see I've got 2,000.42 yards of cut. I could have tightened it up a little more if I wanted to, and there's my side slopes, etc. Okay. You could even use slope groups so that, you know, these back slopes, you could keep those at 2:1, but these you might want to make it 4:1, you know, that any kind of repeated finessing that you can do. So now I've drawn that information, or I could have even, in fact, let's just do it from that. Let's repeat that. We'll get our pad, and I'm going to process it just to make sure it reads it. I'm going to now write the 10, and I'm going to call that my borrow pit as my surface. And so now if I look at that, I'm going to exit that. I've got my borrow pit. Looks like that. Again, in the model tab, I can add this top and you can see it sitting there. You could give that top a little bit of opacity so you can see down where it cuts, but you can see the where they intersect. You can see how it's there. So that amount of material within that footprint and those cut banks would be 2,000 yards of material that I could haul away. And of course you would have, you wouldn't necessarily have these banks down here. You would break that open and have a little roadway that comes in, and that's all included in this exercise here where we go through, designing a road, coming into it, excuse me, put in the vertical profiles and actually come in here to the edges. You can see it comes right into this floor. We gave it a slope so it drains, so it's not at a constant elevation, and that concluded that particular exercise. So that's a nice way of using that design pad to target particular volumes. As I heard you guys were talking earlier about, you wondered how much material you can put into something or whatever you can take out of. So that's, if you needed to design it so that you could hold a specific amount of material, maybe you're doing a landfill cell or something.
Yeah, we do like a lot of waste sites, and the project manager will get with us and be like, "Hey, I need to put, X amount of cubic yards in there," and we'll
Yeah.
have to design it. But that tool, just switching that off, makes it so much faster.
Oh, yeah. And now, in terms of I need to put material in there, you've got a third surface you've got to consider, because if you're putting material here, it's going to have a top that exceeds out. This is the material that's from the existing ground coming into that. If we excavated down to that elevation, so you're going from the opposite side of saying taking.
We're
This,
doing like shooting the original ground, then they'll say, "Well, I need to put this much cubic yards in this area here."
right. So in the case that we just did here, we're talking about the I need this much material number is actually coming from the amount of original ground we take out. That doesn't accommodate the height of how you can pile up that material. Okay, now that is a different approach. And let's see, what will we do with that? Now, how would we find out? Because again, that material can be piled up higher than the adjacent ground, right?
Yeah, you usually want to like tie it into like we'll look for like a little valley or something like that and tie it in, and then maybe come off like 1% or something, so it sheds water towards the slope,
Right,
and then
yeah,
come
I
down
would
at
have,
like a 2 to 1 or something.
yeah, because I would have put a bottom slope on this thing instead of keeping it flat, but just for the sake of time, just keeping that flat. But now there is a routine. Unfortunately, it's not in this, it's in the mining modules, and I don't have the licenses for the mining modules. Again, that's pretty tightly controlled back at Carlson, but it does that very thing. Is it basically lets you design, the bottom floor as to where you go, and then you design the top surface based on an upslope. And you could even, have, benches in it and, roadways that spiral around it and that kind of stuff to come up to those particular scenarios. It's not such a great tool that's going to save you so much time and effort that you should spend the extra money on the mining modules necessarily, I'm going to say. Could if you wanted, but it's neither here nor there. Now you can, at this point, if I'm going to freeze off those pad polylines, and if you do your contouring from a tin file, this time I'm going to use the borrow pit, and I'm going to change these to be different layers. I'm not going to label them. I'm just going to draw these contours. And all right, so I did that. Let me do it one more time. Where I do the existing ground. Now, what happened when I just did that? I'm going to do the existing ground here. I will label, and under contour, I'm going to put this back to those V dash, but I need to, let's see, did I get that one? Did not. V. I need to change this to say, to not erase the previous ones. That's what happened. So there now is my thing. I can move that label around, but there you see the existing contours and you see where the design contours would tie into it. All right, so that's, again, all those little tools, and they're just part of the civil surface type thing. They're not really part of that SiteNet information, okay? So as a real quick and dirty exercise, I'm sitting here trying to think of what I would do is if I had, here's my existing ground. We'll go out and shoot the original ground. Let's do this in a different approach. I'm going to erase those contours. So if I did this, let's put this on, I'm going to open it up to a little different shape here. All right, I'm going to also use Design Pad for this. I'm going to say Design Pad template, and I'm going to make sure I uncheck the previous. Okay. So now, let's see. No, before I do that, I need to drape this line on the ground. So I'm going to say 3D data, 2D to 3D by a surface model. I'm going to target that existing ground. I'm going to now choose this polyline. No vertical offset, add vertices, that's all fine and dandy. I'll say okay. Boom, now it's got this as a 3D polyline that's draped right on that ground as verified. Okay, now how much material can I store within that? Now I could have done, I could cut this down a little bit. Let's, we could do, if I did my Design Pad template, and if I choose to go to, I could go to the inside and have it target a specific elevation to give a floor. let's see, there's another option here to use a separate surface. For the inside. Let me see if I go outside. There we go. If I go to the outside, then I can use another surface for the interior. So I could use that original, if I had a surface down here that represented some other graded elevation. But let's go to the inside and let's target an elevation. So I'm going to, oh, that's the previous pad. Polylines. Let me fix that a minute here. And let's erase by layer. Clear that, select that. All right, now we'll go back to our pad. I should have put that on a different layer down here, but I'll leave this. I'm going to the inside to an elevation. I'm going to say okay. And let's say I'm going to put that down. Here's 395, 96. So let's say I'm going to put this down, say at 94. So I'm going to pick my pad polyline and I'm going to go just 2 to 1s are fine. And my target elevation, I'm going to say 394. So that would be, I'm going to say no, that's fine. And that gives me a certain capacity. And if you were to calculate that, that would be as if you filled it up to match that outside edge. Okay, so we're not going to do that, but we will. I forgot to do the. We'll go ahead and process, and I'm going to, oops, can't redesign unless the surface file. Oh, okay, fine. Can I write the 10? It's going to say I could. I'm going to call this one my waist pad. And let's make sure that happened. So I've got my waist pad. Looks like indeed, there it is. Cut those slopes down to that elevation. Now, so I've got that as a little surface that's just barely cut down in and it's all flat at the bottom. So how much could I put in there is I could build a surface that is just that outside top. Remember, it's draped on the ground, and go up from this bottom level elevation up to that line, calculate some volumes there. But now I want to push this line up. Let's see, I need, man, I don't have I would need to know about how high that other information, how high would that be? All right, so I could do this. Let's generate these. If I offset, if I did a 3D offset on that, is this also my 3D? Yeah, it is 3D. So if I do a 3D offset, and if I go to a constant or to a surface, let's go to a constant, which would be an elevation. Let's say, okay. Now, let's try to see that. I want to go to a surface. I want to go to a constant elevation. All right, let's just do that and let's see. You go say 30 feet. And the common elevation there, I'm going to call that 410. I'm not sure this is going to work. All right, so there it would be. So now if I were to model this and this, let's say that was going to be the top of that. Now that went up at that 2-to-1 side slopes, I think. No, let's say I went out a certain distance to a top. So that really wasn't the approach I needed. If I went, see, I can't do that edit. I can't run the balance on that. And if I go to a targeted elevation, let me try that. Instead of an interval, if I do, see, I don't have a surface either. All right, let's try constant again. And let's do a ratio of 2 to 1. All right, there we go. At 410. Let's make it 415, a little higher even. All right, so we're going to offset the outside edge to the inside. All right, so now we're getting somewhere. If I take a look at these guys, so that would be right now my targeted surface. So I would build a surface from out of this right here, adjust. No, see, okay, let's see. If I use this as my pad, yeah, there we go. If I then said design pad, I'm going to target a yeah, I'm going to target a surface file, which was my waste pad. So I'm going to go from here to my waste pad at 2-to-1. Oh, sorry. Let's undo that. We got to go to the outside and not the inside. So we're going to go to the outside now. We pick our pad. We go to the waste pad. 2-to-1, 2-to-1. All right, so there's now that. And let's see what that looks like. So that would be, that comes down. You see that line there is the intercept of that little prepared bottom. All right, and so now if I edit that, if I do a design pad edit, or edit pad template, if I choose that one, process, and then if I balance, so how much do I want to bring in? So give us an example. There's 3,000 yards of material it will hold right now. So if I only need, say 2,500, I would put that in and say, okay. And so it drops it down. So that's really you know, where that would be. So I know that my little prepared pad can hold that amount of material. And then I could even throw this waste pad away if I didn't prepare the bottom. If I'm just going to I'm just going to lay this material down on the existing ground. I'm going to, let's exit that. And I'm going to erase. Let's see, that's on layer pad. I wanted to put that. Put it on. Storm isolate now. That and that and say that. All right, so now that I've established that, that's going to hold that, but it went down, it targeted that little prepared bottom. I can now take this line here and use my design pad template again, go to the outside, target the surface, and let me set this again to erase these previous. I forgot to get rid of those. So I'm going to pick my pad polyline now. And I'm going to target, instead of that waste pad, the actual existing ground. At 2 to 1, 2 to 1. And so now there's that one. I'll say no on the redesign. I will now do this repad, which is the pad edit. I'll pick that pad and process that. And that's 1,275 cubic yards down to the existing ground at that area. So if I want to do the balance again, I needed 2,500 yards. It'd be 500. So that would spread that out as such. Let's go back to my top view for a minute, and you can see I probably shot off the edge a little bit over here. I did. But that gives you a, you know, a couple of ways that you can approach that problem. You can set up an area that you're going to be using, target that, and set up this top material. You can, let's also get rid of this pad layer stuff. You can also then target this other, if I do a design pad, and I'm going to target, instead of a surface, this screen entities. And I'm going to choose, let's see, pick the first corner of the pad disturbed area. This is why it's got to build this little cell, dimensions of a cell. Let's go every 5 feet. So it's using gridding to do this. So I'm now going to pick, this is my pad, 2 to 1. Oh, it's looking for, target something, target the screen entity. It didn't let me pick it. So if I do that, pick the first corner of the pad disturbed area limit. Yeah, see, that's actually trying to come up with that as a limit. So ignore zeros, build us the grid. Okay, pick the pad polyline, not the target, but the pad. Yeah, see, that's, yeah. And I don't know that it's gonna let me edit that because I didn't go to a surface. Yeah, maybe, let's see, balance, yeah, I can't redesign unless a surface file was used, okay. So it would have to be that previous approach that we just looked at. Where we'd set that up and then come up with this as a targeted, let's try this height type thing and then see how much we can fit down in there. Like I said, the mining module has a routine that lets you take that outside boundary and push it up to you either reach an elevation or you reach a volume. So you can, that's part of that mining software. And it's not real. I must say, I've used it before, I've trained it before. I'm going to say it's not foolproof. I think doing it this sort of trial and error basis might be just as easy. Okay. So does that give you some ideas maybe to explore to help that process, I hope? And
Oh yeah, there's definitely going to be some tinkering around with seeing that.
oh, good, good. All right. So yeah, use those things to your advantage. And you've got this other design pond, which of course goes down inside. You've got Valley Pond, which is a slightly different approach. But this is sort of like that borrow pit that we did, that you could consider that to be a pond if you wanted. But it's really, excuse me, nothing different than this design pad template. It just changes a couple of the promptings and it can accommodate benching and stuff in the top. So it's, a little bit more finessed. But I think for what we're doing here, doing some waste areas and borrow pits and such, I think that would get us where we need it to be. All right. So let's take a look next at some of those roadway tools. We'll set that up and then actually what we'll do, we're coming in. Yeah, so let's open up a file and we want to look at our roadway design base. And I'm going to show you a couple of things about that too when it comes in. And then we'll take our afternoon break. All right, now right here we've got a file that was actually provided by Autodesk as part of their training materials as an existing terrain. But notice if you go to pick on one of those contour lines, the whole thing lights up, and I look up here at my properties and I see that it identifies that as an AECC DB surface. So that tells me right away something's up. It's not just a block. Now I could explode this a couple of times and get it down to just the drawn line work. But here's what happens, and we need to be sort of aware of this when you are dealing with files from outside people that might have come from Civil 3D, because if they give you that Civil 3D drawing file that still has inside it those surface objects, alignments, things like that, then you need to sort of be aware that that might be what's going on. So I've got that selected and I see that it's something else. All right. One of the first things I always do when I get files in from somebody else as well is I always do this little spin up. Now watch what happens when I let go. See how that changed views? That is characteristic of a Civil 3D surface object. When you're looking at it in plan view, it shows you the contours. When you look at it in what they call model view, it shows the surface. Now I could change my, instead of wireframe, I could go to my realistic. And so now you can see, hey, that's the actual surface that they gave me. And I can see right away, see these little shaved off hilltops, this is not a very well-made surface, but that's what they got. All right. So I'm going to go back to my plan view here, and I know that I've got something that I can do with this. And if I know that this came from Civil 3D, you can go to that file, drawing cleanup, clear this out and say convert Civil 3D concentration points into Carlson format. That's one way. The other is under file, import. There's a whole Civil 3D menu where you can bring in, any Civil 3D objects, including, centerline alignments, profiles, pipe networks, parcels, points, surfaces is the big one. Now, the only one that's in this file is this surface. So I'll just choose surface, and it says, well, for a more complete conversion, we recommend saving the drawing first. All right, so we'll save it. And now it's going to go through all of this, and it says, hey, I found a surface called Phase 6 Original Ground. You want to create a Carlson 10? Well, yes, we do. And we'll just keep it the same name. And it happens to already exist, so we'll say go ahead and overwrite. So now what happens when we converted that, if you click on that now, it's just a polyline on the layer called C Topo Minor. Here's one on layer called C Topo Major. And that was what was defined in that original Civil 3D file, okay? So if you followed that along and you've gotten to that extraction point, go ahead and save your drawing. We're going to go ahead and take our little 15-minute break here, and we'll leave us with a good hour to finish up the day. Any questions at this point? Did everybody get this to this stage? Anybody have a problem? Nobody? Good?
Good.
Oh,
Good.
no. Go ahead. It was just a confirmation. Okay. If you should happen to have something like this and you don't see that surface behaving like that when you spin it up in 3D, or you look at it and it does not recognize it, that's because you need to install an object enabler for Civil 3D, and it comes with some pre-built into the Carlson installation. It usually would work, but sometimes you might have to add that to it. Sounds like everybody's worked. So let's do that. So let's pause this as well. One of the things that you can look at, I think it's included here. If you go to the help system in the Carlson manual and you look in these tutorials in these CAD basics. Now, I'm not sure. I'm just guessing that they might have something here under plotting. But maybe not, because it's a little bit, yeah, it doesn't in there. So that would not be the thing. But what I would recommend doing then instead of that is, if you were to go to, let's say, your YouTube, and we looked for plotting in AutoCAD, for instance. Yeah, there's different courses, but a lot of this stuff you can get with just the, here's different like plot styles, print and plot your drawings. It's just a little 5-minute thing.
Once again, we're staying in our design intent.dwg file, and
they're
you can
showing
see there
using
that we've got our
viewports.
annotative scaling working in our
Yeah,
view.
yeah, I like that. I've done that a couple times with like multiple
Got a-
viewports in there. If I'm running like a profile on there, and maybe like a quick little cross section view, and then like an overall plan view of an area, that I want to highlight or something.
Right. And you could do like the sheets scale and export. There's another, it's like 8-minute video. So they're just some really good.
I finally figured out the
it
real
might be
difference between a
something,
Masato knife and the ordinary stuff. We've all seen those flashy.
might be that this is sort of architectural based and all that, because this guy is an architect.
This is the
but,
Balkan architect, and in this video I will
does
show
that.
you how to prepare sheets in Revit, how to set them up, and how to
That's in
prepare
Revit.
drawings in the correct scale.
Wouldn't focus on that, but you can find a lot of these little things here that can help set the stage, and what you want to learn about are how to set Well, here's how to plot from model space. Well, that's the way we always used to plot, and I don't ever do that really much anymore. I always plot from paper space, but you need to know how to set up those layouts, how to set your paper sizes, how to set the scaling of what you're looking at, and you can have multiple viewports at different scales out of the model. And a lot of people do that, and they always use rectangular viewports, but they don't have to be rectangular. You can draw, you know, in a regular shape and call that a viewport. And you know, use
Yeah, a
that.
lot of times I'll plot out of like 11 by 17 because that's what we have that I can print out of. But I don't know if it's better just to do like the full size sheet and then just scale it down.
Not necessarily. You can, or you can actually have two
Hmm.
um, different ones. Or if you plot to a PDF file, you can always plot a PDF file to print the page or to fit to the page, what, you know, at the
Yeah.
outside of AutoCAD, just when you're, you know, printing the PDF. So there's a number of different ways there, but a lot of these layouts and stuff, that's where you're going to put your title blocks and there's all kinds of automation you can use. There's a thing in AutoCAD called Sheet Set Manager where it puts together various sheets from one or multiple different DWG files into what's called a sheet set, and then you can print that whole sheet set all at once. You know, and it opens up the drawing files that it needs to get at those paper space layouts and puts them in there. But the other one thing to um, sort of pay attention to is when you're doing these, let's go to this paper space layout. Now you see this on screen, it's showing as they're actually, you see that, I don't know if you can tell, it's so lightweight, but you can see they're sort
Hmm.
of
Yeah,
rounded.
those little yellow ones.
Then, you know, make sure you use a style table if you're using color tables, or if you're using a style table, which is a different story. And that's, they tried switching you from the color table method to the style table method about 20 years ago, and the whole industry just rejected it. So, but then once you choose this, make sure you check this box right here to display the styles. And then when you close it up, now you see I put it down as
Hmm.
grayscale, and you can do that, and you can edit those tables and tell it where if you have an item that is a particular color in the model, use this color, use this line weight, use this line style. So you can remap all of those different things. Put my line weights back on so you can see this stuff.
Yeah, I never even knew that little tab in the bottom right there for like the different to display the line weights.
Yeah. Well, it
Yeah.
may not be showing. You'd have to make sure that when you're setting this up, let's see, where is my, here it is. You right click that farthest icon and you can turn on the different things you want to see down here in the status bar. And so
Hmm.
I make sure that I have my coordinates are showing, which is that cursor coordinate values. Now, one of the things that you can also do in those cursor coordinate values, and it doesn't make a lot of sense here in the paper world because I'm in one-to-one, but if I'm in my model space, um, if you right click in there, you see I'm using absolute coordinates, or I could go to relative coordinates. If I'm drawing a line, it shows me how far away from where I started, that kind of stuff. I can do geographic coordinates, so it can actually read me, um, you know, and I'm not set to a particular state plane projection, so the geographic, you know, wouldn't work
Hmm.
here. That's why it's staying here on decimal units, but you can change the different units. Um, you know, look at your coordinate settings as to what you might want to see displayed. So there's all kinds of things that you can do down here that is just sort of hidden. You just have to right click and look at things, look at settings. Same thing in your snapping. If you right click and look at your settings for your snapping as to what's turned on. Like
Yeah,
I,
because you can save all these like customized settings and stuff. So
yeah.
like, because I've had to like switch and go to a different computer before, and then
Mhm.
it's just like, oh man, I wish I would have saved all my settings, and I gotta like go through and customize everything again.
Well, yeah, and there's like this is what I normally have: endpoints, center points of circulars and arcs, and midpoint and extensions. Now that's because that lines up with with the work I do in MicroStation. That's the way I have that running. So I like
Mhm.
those as my running. So you can override those at any time. But now that sticks with each drawing. Now there's a couple of things about saving the settings. You can, if you go to the this would be the IntelliCAD options under the settings menu. Nope. Yeah, there's a tab here called profiles, and that's where you can, create one and you give it a name, and then you can copy that profile over to the other computer and then reload that. And that will take care of all the settings like where your toolbars are located and the menu
Mhm.
sets and all that. But the other settings that you want to make sure if you want to transfer, let's say you're doing a lot of surface modeling and you've set all of these layer names and labels and all that kind of stuff, you can come down at the bottom and save that as a settings and put it somewhere, maybe put it on the network, go to another machine, and you just come into here and choose load settings, and it reads everything, fills out all the answers that you had in the other settings. And that's done pretty much on a on a command by command basis. Any of those dialog boxes that you fill out usually have those down there. For instance, if I were to go to my center line and I wanted to station a center line, all of these settings, the intervals, the heights, the markers, you know, the
Yeah. Yep.
Z's and spirals, all of those different things, you can save and load those settings. Now, you can do all that there at individual different places. And again, if you were developing drawings for different clients, it wouldn't be so much on your end, but on the design engineers, like maybe they're working on a PennDOT job or a Turnpike Commission job, they might have different layer requirements and text styles and things like that. And that's what you would use to set that. Now, that being said, let's say you've got your machine humming along just right the way you want it. You got all your settings and they're perfect. You could go up here to your settings and choose Carlson configure. Now, this is the top level. This is everything. And if you save as, and then you go to the other machine and load that same files, and it saves. If I save all these settings, I'm going to put this one in, this one called training defaults too. I'm going to save it. Now, what's the number that comes up here? So it's going to save 97,311.
Oh yeah.
Okay. So that lets you very quickly just replace that whole system with the way you like to work on yours. Okay.
Hmm.
Now, it still doesn't do things like if you had, let's say, whoever made this file, if they did not have this, say, link line work with center lines, if that was checked off when they made the center line, for instance, just because you loaded it up or you turned that setting back on, it's not linked. It's the way it was when it was created. And so you don't know because you don't know what the other user did, maybe.
Yeah.
You can find that out if when you double click, an alignment. We haven't turned it into an alignment yet. If it is not linked, you can make a change in the centerline definition and it doesn't update the graphics. A simple way of fixing that is to just erase the original graphic and go back and say on the centerline menu, draw the centerline file. And then once you've created that from this command right here, now that graphic is linked to that centerline file as long as you had that switch turned on at the time that you drew that centerline file. So, just be aware that a lot of these, anything that's created behaves as it according to the settings that were in play when it was created.
Hmm.
Some of
Yeah, a
those,
lot of times I like to take all like the paper set of plans and kind of like make my own off of the plans itself instead of getting the designer file. But I know everything's getting moved to that, digital delivery coming up.
yeah,
They're talking
yeah.
about.
Well, we're hoping, like I said, that's my Don Quixote windmill is to try to get everybody to play in the same team.
Yeah. My only thing is like, doesn't everybody use different software to develop? So if somebody's using like Bentley and MicroStation, is that going to play nice with,
It's
Carlson
getting
and
there. We're still years away from that, but it's getting there through a technology called digital twins.
okay.
And that's becoming the way we deliver data on big projects. And so it doesn't matter what software you're using, as long as you can read that digital twin, you've got all the intelligence that's behind all of that modeling. Excuse me. And some of these early attempts are, using technologies like land XML to transfer the civil data. And so that gets alignments, profiles, surfaces, points, parcels, pipe networks, all of the things that you typically do, regardless of the system that's been used. But it relies on the designer to be able to save that data out into a land XML file and deliver along with the drawing. And the savvy ones will do it. Those that that aren't so savvy wouldn't necessarily make that
Yeah.
happen. So now, all right, so let's get back to our little roadway example here, and we'll coast through this and call it a day. So we've extracted our surfaces. We now have these as drawn polylines as if we had said contour from a surface file, and we can verify that we actually have that surface file now called phase 6 original ground, and we can see it in our viewer. And let's turn off the contours for now. So you can see, and that's the same as what you saw out there in the drawing file before we did the conversion. I see, like I said, these little sawed off mesas. And I see, a little point down here that's probably not correct. There's just some little gotchas, but we're not going to, spend our hour tracking all that crap down. We're just going to use it and call it a day. You can even see that down here with that little contour. And maybe it's correct. Maybe it is a little pile of something down there. We don't know. I see an instance here where I've got a drawn contour line, and they've drawn, and it's jumped across and connected. Now that is an elevation of 110, and it connects over here to this one that's also at 110. So technically that segment should not be there. So I should be able to, take that out and then make sure that this is actually should make sure it's closed. So I'm going to say, yes, close it. And so now, that's gone away. And you see little jiggies there and there that's based on that surface modeling. Here's another instance right in here, that kind of thing. I wouldn't go through and fix all that if I'm just building this. Now here's an example of that contour runs this way. It's elevation of 110 also. And here's this little contour here that's also 110. And then there's this little segment right here that's 110. So I would probably either fix this contour if I was worried about the contours, just to come around the corner and get rid of all this other convoluted mess, or just erase these things here. Now, having done that, I didn't change anything on the surface whatsoever. Okay, all I did was take out the drawn contour. Okay. So again, I wouldn't, spend a lot of time chasing that kind of stuff down. All right. So what we have here now, we've turned that back into our surface file. We got some contour drawing issues, but that's fine. That's the way Civil 3D did it. But I'm going to spin this thing up one more time and show you. Now I'm in this realistic view. If I go back to my wireframe, which I'm typically in, I can see all of these different things. If I select one of those guys, I see those are a bunch of 3D faces. All right. And what that comes from is in the surface object that came from Civil 3D, it was set to display the what's called skirts. So it goes down to a reference elevation down here and just shows these to sort of give you some perspective on, what that surface looks like. We don't need them. It's just basically hogging up our drawing. So I'm going to erase those things out of my drawing. So I know that's a 3D face. I don't have anything else that I need to work with out here that's a 3D face. So I could select all these 3D faces, and you can do that several ways. If you select one of them and right click and choose select similar, then I see up here I've got 858 faces, and I could just, now that they're selected, I could hit the delete key and get rid of them. That's one way. The other way to do it is if you isolate the layer, so that everything else goes away, then you could just do a window and erase all that as well. Likewise, you could, instead of pre-selecting one, you could go to right-click the menu with nothing selected and choose Quick Select. And this lets you select things quickly. So I'm going to apply this to the entire drawing, the entity type, and it only shows you the things that it finds in the drawing. So that I'm going to say face. And then you could further limit it to say a layer that equals or is not equal to a particular thing, or you could just come down here, instead of that saying equals, you could pull this down and choose select all. So I'm going to select all faces regardless of any other filtering, include in a new selection set, or if you were selecting a bunch of different things, you could append to a current selection set. So we'll just make a new selection set. We'll say okay. I look over here, and now there's those 858 faces also selected. And then I'm just going to delete them. And I did that because this boundary, this outline of this surface, is also on the same layer that those 3D faces were. So I didn't just isolate the layer, because I would have gotten rid of that drawn boundary. Now I can always recreate that boundary, remember, from our surface menu. When you draw the surface boundary, and you can do it as a 3D or even as a 2D down at 0. So a lot of ways you can do to clean a bunch of this stuff up. And so now let's go through and do our road design. And I'm going to refer you to a couple of pages in your civil manual here when we get to the design stage. Here is we're going to look at some roadway designs, and here's what you would typically have. You would get this from your design plans, you know, your cross slopes, your materials, your subgrades, all of that, and your catch slopes, things like that, is a particular cross section. And now one of the things that you need in this stepwise approach for road designs is you've got to have a center line. That's the alignment, or the horizontal alignment, typically at 0 elevation. That defines your horizontal extents. And then you have to design a vertical alignment, or a profile, that follows that, tells it how to go up and down. And then you would design a cross-sectional shape, or a template, and that would be, anyway, sorry. That would be, you know, this cross-sectional shape that includes the materials. And then as an option that you want, because you can then process that, you wouldn't, and you could just process just the roadbed itself, or if you have a design that defines the existing ground, which we have now, this phase 6 original ground, then that can be used to tie with these catch slopes, okay? And then that will accumulate all of that material in our material reports. Okay, so that's what we're going to look at doing here with this. So the first thing we need is an alignment. Now, again, this could be any kind of alignment. It could be, you know, a sewer line between manholes. It could be whatever. I've got a drawn polyline. I select this line here, and I look at it's just a polyline. There's nothing special about it. That's going to be where I'm going to start, and I'm going to stop the alignment over here. So you can draw, and sometimes you'll see those 2D center lines drawn with curves in them and the whole works. If it's already existing, let's go to our centerline menu and choose polyline to centerline file. Okay, so it asks us for a file. We're just going to call this main. Yeah, let's see, those are already in the data set. Let's call this one, oh, we'll call it Elm Street since Freddie lives there. All right. Now it says, select the polyline that represents the center line, but read the line above. It said it should have been drawn in the direction of increasing station. So it should have started up here at this alignment and or at that point and go toward this point. Now, when you choose that, that's just information. So select the polyline. And when you do that, you're going to get little markers that shows you the direction it's drawn in. If it were drawn the other direction and you wanted to reverse it, you have an option down there on the command line called reverse. All right, but we're going to take our beginning station of 0 plus 0. We'll just take that default. And it runs through a bunch of information down here in our command line, and it gave these LIs, which means line intersection. So those are your PIs, really. And then press enter to continue. When we do that, we now have created a centerline file called Elm Street. And because we had the linking turned on, watch what happens. First of all, if I double click a contour line over here, it's just a drawn polyline. If I double click that, you see it brings up the AutoCAD or IntelliCAD P-edit command. But now if I double click this guy, since we've turned it into a center line, it brings up Carlson's centerline file editor. And I've got these individual pieces. And now watch also here. If you sit on that first segment and you're going to fit a curve, I'm going to come down here at the bottom and choose fit a curve. This is much like doing a fillet on a polyline. And you could have done that first and it would have read the curve and put it into the alignment. But we're going to fit a curve in there. And let's give it a radius of, well, let's say 125 feet. And we do that, it fills out all the pertinent data that goes along with a curve radius of 125 feet, and it assumes tangency. Now, this is more for design than it is for building. You would base it on the existing plans. You would put in those values. But you can see part of your design assistance is to look up horizontal speed tables, and you've got these different tables you can use, a design speed and what your minimum radius and all that kind of stuff is going to be. We're going to not deal with any of that, but I'm going to go back here now and put in a 125-foot radius. There it is. I'm going to say, okay, boom. There it is. And there's that little curve that would happen. Well, maybe I want that curve to be bigger than that. So I'm going to sit on the curve and now double click it or choose the edit button. And let's make that instead of 125 feet, let's make it 250 and see if that gives us a little, oops, it's too large. I said 2250. I'm going to watch what I'm typing here. So if I say 250 and say, okay, now you see it's a little bit better. All right, so I'm going to come down here to this next line. I'm going to fit another curve in there. And let's make that one a radius of 200. And say, okay, and that puts that curve in there as well. Now I'm sitting still on these little lines. I can now, if I wanted to shorten that up, I could double click that line to get the line edit and change, things about it. Let's say instead of 638 feet, let's say I made it 475 feet. I say, okay. And now you see it's shortened this, but it's kept the curve. It's kept this last piece. And now when I'm out here in this plan view, when I say save, now watch what happens when I choose exit. See, it updated that whole thing. Now here's another part of this editing. If you select it as a polyline and you just take a grip and move it somewhere else, let's say I put it back to where that was, Okay, and now if I double click that again, I can see that new shape. Well, managed to. What was it up here? See if it comes back here a minute. Let me switch off of it. Close that a little back. It's not.
The computer knows it's Friday.
Yeah, apparently so. All right. Let me. Here I was bragging on Carlson is not crashing all that often, but yeah, it does say not responding. So I'll just end it and rebuild it pretty quickly here. Let's go back. Come on, load up what you need and get on with the show here. All right. Now, once I get my menus up, I'm going to close off these toolbars here for a minute. Get them out of the way. All right, so I'm going to import Civil 3D Surface. Yeah, I was going to save the file. There it goes. And everything's there. I'm going to quick select my 3D faces. Once you select all, say okay. I'll delete them. And now I'm going to go to centerline and do polyline to centerline file. I keep the same name, place it. Yep, I'll get this. Enter to continue. I'll now double click that into my editor. I'm going to fit a curve of 250 feet. Say okay. I'm going to come down here and fit a curve of say 200 feet. Say okay. And I'm going to actually shorten that up because I'm awfully close to the edge of my surface back here. So I'm going to double click my line. And change that from 648, I'll make it 500 feet. And say okay. Save and exit. So anyway, what I was actually working toward there earlier was the fact that even if you make graphic edits out here to this polyline, it's going to update that centerline file. I won't risk the Fridays here again. So we now have a centerline. So the next step would be to design a profile, and you could do that on the profile menu. And you might choose just this profile editor. Now this is just a generic editor, and let's do a new one. Just call it test for now. And you can see you can have a different type. You have a generic profile, a road, a sewer, pipe, different things. If I choose a road, I'm going to come down here and choose a reference center line. And I'm going to choose that Elm Street. So that's now going to be my reference for that. And my reference profile, that means if I would like to see the existing ground underneath it. If I go to set, you see it needs to have been built. I haven't built it yet, so I would have to go back to my profile menu, create profile from surface file, save it, etc., etc. And you can do all that stuff here with this generic editor. However, when you're doing road, I'm going to exit that. When you're doing road design, there's a separate one, and it's called, under the profile menu, it's called Design Road Profile, using the Road Profile Editor, and it gives you a lot more tools. So in this case, we'll call this one Elm Street, just to match names. And it wants you to see, it's telling you you're going to need a centerline file to match against. So, okay, that's good. I've got that. And it wants to know an existing ground so it can cut that ground surface for you. There's that original ground. I'm going to open that up. And now you can see in your editor, and it gives you a little marker as you're walking around the line. You see those green triangles. That's my PC and PT, that PC and that PT. And that's all governed here under this setup button, where you can tell it that you want to show, and you can show, offsets from the center line, left and right. And if you show those, you're going to see them show up here. So you can see the cross slope a little bit. I'm going to just turn those back off. And this centerline special stations, that's what these green triangles are, the PCs and PTs. Now, down below, I'm going to say output the reference surface profile. I'm going to give it a suffix of -ex. So I'm going to, whenever I save this edit, it's going to cut that profile and save it, called elmstreet-ex.pro. And that lets you, right down here, there's that surface that it asked me for when I started. You can change it to a different surface if you need it. And then, you give it a design speed and all of these kind of different settings, but let's, I'll leave that to your own investigation as we go through some different things. You've got your vertical exaggeration of a fit, or a one-time vertical a 1 by 1, so it's not stretched, however you want to do that so that you can see the relief a little better. All right, so then fit is probably a 5. I'm going to tone that down a little bit to 2. And so now what we have to do is insert our vertical PIs. So you notice it starts at station 00, your little green marker here in the profile view. And it sets that station value, and it goes over here and it puts the depth right on the ground. It's a 0 depth. It goes to the end and it does the same thing. Now, the reason it's not exactly 0 is that it computed, something like a slope propagation out, or maybe subtracted these, and there's some round off errors. So you can, if you want, just come down there and make that exactly 0, and it says it right on the ground, but that was, 12 10,000ths is not going to be noticeable. Now, in here, you can go down below and choose Insert PVIs and fill all that out, but we have a nice little graphical editor. And right here is this little plus button, means to add a PVI. The pencil means you're going to edit the PVI. So if I add a point of vertical intersection, I'm just going to come up here and click, like right in there at just on the screen. And so now it finds the station and the elevation of where I clicked and computes these slopes in and out. And it right now would set a 0 length vertical curve, computes my sight distance. But notice these resolution snaps. I said for the station, go to the nearest 5-foot even station. For the slope, go to the nearest 0.5%. You could say none and it would read it exactly, but that's why it's a station 805, and it set the slope at 12 and -2. So if I say okay, you'll see that come in as a PVI, and there's no vertical curve there. Okay, there is if I click on this, and you see that little marker here now. So at that point, you could give it a vertical curve length or give it a sight distance. Again, let's make that, say, a 200-foot. And so that puts that in play right there. Now, I might want to, instead of climbing all the way up to that point and back down, I'm going to put another one over here. So I'll hit my plus button, and I'm just going to sort of click down in here a bit, and I can go ahead and put in the vertical curve distance. It keeps the last one. I'll call that one, say 150. Did I get it 150? Yep. And I'll say, okay. And so now it put that curve in there. Okay. Now, this is absolutely bad design, according to the American Association of State Highway and Transportation Officials, or what we call AASHTO. They tell you never design a vertical curve along a horizontal curve because it can break up your sight distances to where you can't see the road ahead. It's what they call a broken back curve. So, you would maybe want to put that in a different spot, or in our case, for sake of time, we'll just leave it where we put it. Now, to make these edits, if you want to try to line up these so that you got the least amount of cuts and fills and things, choose the edit tool, the pencil, and now you don't have to snap. It just says edit, click and drag. So you click and hold the mouse. And as you do that, you see what you're doing with this curve. So you can, pull it up and down. And so I'm going to line up that tangent coming in. So I've got minimal cut in that tangent. And let's see. And then that uses that to get up to this one. I'll go back and hit edit again, and I'll grab this one, and I can move that up and down accordingly. So I'm going to sort of try to see, where I can come back down in here. I'm lining up on that tangent. Now I've got a substantial amount of fill right in here, and you can see in the plan view, that little marker that's trying to fill in between those two little hilltops. All right, so I might say, well, okay, I maybe want to move this curve a little further along and maybe change this down, but I'm changing that slope. So one of the things you can set is this edit mode, where if you tell it you want to hold the slope in, or hold the slope out, or hold the station or the elevation. So right now it's just in free mode. So if I hold the slope in, for instance, and now come up here and edit, and I move this, you see I can't change that incoming slope, but I may want to just slide this around. And you see what it's doing is I'm going to sort of visually try to match, my cuts and fills and that sort of stuff. And then maybe do the same thing up here with this one. Let's see, you'll pull this down, but that's not, maybe you'd even put another PVI. In fact, I'm going to drag this guy back to here, and let's add one more right in here. And let's make that one, let's say another 125 feet. Say okay. And so now if I edit that one, I can adjust that back and forth. All right, so you see the idea of what you can do with these. Now, not only this holding the slope in, I'll go back to free mode, in which case I can, freely pull that down, and I see I'm just sort of eyeballing the areas under there to sort of get my match. You can also, down here in the setup, tell it when you are dragging the PVI that's down at the bottom, you want to hold the vertical curve length, or if you hold the sight distance or K value, then watch what happens when I go back to edit this now. If I edit this, you see the curve length is going to change because it's always holding the sight length, or the sight distance that I have available. Now let me come back and pull this one. Oops. Let me undo that. So I've got a curve, a curve, a curve, this curve down here. So if I edit that, no, it's not liking that. I'm going to go back to this setup and choose hold the vertical curve length. Choose this, and I'll see if I can pull this down a little bit better. There we go. So I've got fill, I've got fill, I've got cut. Let me keep that up to there. And let's say maybe I didn't want that one anymore. I could just come down here and sit on that one and just remove that PVI. So now that's gone. And if I edit this, you see I get more of a straight line. And let's maybe make that a little bigger curve. Instead of this 93, let's make that 150 feet. There we go. So that's looking a little better. Now, if my crosshairs are in this upcoming slope, I look up there in the top of my window and it tells me that's a 24.5% slope. Well, that's a pretty darn steep road. All right. I would not normally design something like that. That would be way outside of my specs. So I'm going to change this down here a bit. But now what that's going to do is give, now I'm down to a 16, almost 17% slope. So, you know, it's not an ideal site, but those of you know, there's 18.3 and that's 11% down over there. Those of us here in Western Pennsylvania, Ryan, I don't know what you're like out in your part of Oregon, but that's not uncommon. You know, we've got some crazy sides. Anyway, we've got a profile pretty well done. Let's save it and exit. So now we've done that as a different approach. The next thing we would do is create our design template. So we're going to go to that and we're going to look first at our existings. We've got some things here. I've got just, and you see the little picture, it's just got the top surface. We don't have any subgrades added yet. And you can do the road design that way, and that's all it's going to generate. But let's make a new one. And let's call this one a 2-lane rural. Oh, let's go ahead and put curbs in. I know we're not going to put a curb out there in the country, but we'll do that. So now this is going to bring us up to this nice little editor. And we're going to say, for sake of simplicity, that the right surface is same as left. So this is grayed out. We only have to build it here, and you'll see it build from the center out. So I'm going to start, first of all, with my grades. These are the top surfaces. So from the center line, I'm going to do a slope in percent of -2%. And I'm going to go a distance of, let's see how, let's make these 12-foot lanes. And we're going to call that our EOP. All right. And we'll say, okay. So now there's that one. I'm going to add the next grade. So I'm now at the EOP, or actually the EOP, I'm going to put in a curb. So I'm going to say curb. I'll just choose this in inches. I've got these different types of curbs. Let's use this simple one here. Let's take the default values to what they've got. You know, you would set that up accordingly. We're not going to get into the nuances of all that. We're going to call that a CRB. And we'll say, okay. And so now you can see your curbs. And you can actually, I've done this before, whereas if I change that to be right instead of left, you see how it switches those around. I've used this to make raised median islands within another road, you know, within a road, and lay that right on top of that road. So, but by default, we'll keep it there. We're on the left. It's a left-facing curb. Now, I go to my curb, make sure that's active. I'm going to set another grade. And this time I'm going to set a positive 2%, and I'm going to go 4 feet out, and I'm going to call that let's just call that hinge. All right, so there's now my hinge points, and I'm going to go to my cuts and fills, and that always attaches to the outside. Right side will be same as left. We got it cut there, and I'm going to make those just 3-to-1 cuts. You can add ditches and berms and all kinds of stuff. That's more for the civil class. We're not going to worry about it. So if we tell it what we want to display left and right, it's just showing you that. typically we put, you know, one condition on one side and the other condition on the other, just to see what they look like. I'll go to my fill. I'm going to do the same thing and just make that a standard 3-to-1. And again, you've got all of this stuff where you can hinge around super elevation, subgrade points. There's really kind of a lot of complexity in the design. You're not going to do that. You're going to build your sections, your templates based on your design plans. You're going to get those little details and just mimic those. All right, so for now, we've got this little 4-foot positive drain to the curb, down to the curb, and that's now our road top. Okay, so we're done with that. We need to add some subgrade. So I'm going to go to my subgrade button, and I'm going to use these subgrade types, you know, under the roadway. We're going to do a distance out. We're going to match the surface. Their slope of that subgrade is going to match what's above it. And my intersect surface is going to either be straight up, so I can leave it as straight up if I want. And the horizontal offset is how far away from this center reference point you want this subgrade to start. So I'm going to leave that blank or make it 0. And the vertical offset, and again with these units, I'm going to change it to inches. Okay. And I'm going to go down 2 inches. And how far away do I want to go? Well, let's say that was 12 feet. So if I did, let's just make this 10 feet just for example. And this is my, you know, my top coat asphalt. Then you can do all kinds of different things. You can hit the set button and pick it from different materials, et cetera, et cetera. What do you call it? Top coat asphalt. I'm not pivoting any of that. I'm just keeping everything normal. I'm saying, okay. And now you can see up here, it went 10 feet out and went straight up. Now I'm going to go back to that. I'm going to come down here, select it and double click it. And I'm going to change that from straight up to continue the slope. And when I do that, it's going to go all the way out until it hits something, either another subgrade or something else, so it hit the curb. So that's one way to handle that. But here's the preferred way of doing that is instead of specifying a specific distance, you can type in one of the grade IDs or select, there's my EOP. So it's going to follow the EOP. Now, the reason I do that is I may have other conditions that might say, instead of making a 12-foot lane, I want you to follow this widening path. And so the lane goes from, say, a 12-foot to a 16-foot or another, or 24-foot, maybe adds a second lane. It's going to follow that EOP. When that EOP changes, it's going to go right along with it. So that's why we're doing it that way. So that's now my first level down is that asphalt. Now, that was 2 inches. So I'm going to do another subgrade. And I'm going to make 8 inches of stone underneath this. So I'm going to keep my offset at 0. My vertical offset's going to be 8 inches. But now, here's what I want you to be aware of. So it's 8 inches, you would think. And it's also going to be, let's go to the EOP, but we're going to add an additional 2 feet. And this we'll call stone. Obviously, you give it like, you know, AASHTO number 57 or, you know, 8B or whatever you wanted to call it wanted to show up in your reports. So now if I do that, and I said straight up, so it goes out, it's 8 inches deep and it comes down here and goes straight up. Now that 8 inches, if I were to actually measure this, that's a 6-inch curb. So 12 or 2 inches, then 4 inches to the bottom, but it looks like I've only got, you know, 2 more inches here. I need to be, instead of 8 inches for that, because if I want it to be 8 inches thick, I need to specify that as to be 10, because I have to go, remember this vertical offset is from the top surface. So I've already got a 2-inch layer above it. So I'm going to go 10 inches deep. And so now I've got 8 inches from the bottom here down instead of 8 inches from like you saw before. So this now comes around, it goes out that additional distance and goes straight up. So that's stone behind the curb. One of the other options instead of straight up is if you put that back to continuous slope, and you see what happens with that is it goes out until it hits the daylight. But one of the things that we can also do is what's called a wraparound. And the wrap height in inches, I'm going to just make this, since we're 10 inches down, let's bring it up 6 inches and see what the effect has. So it's going to come up 6 inches and tie back into the back part. So it tries to get back to the start and it hits this and stops. Okay, so let's maybe make that a little bit more. Let's give it an 8-inch wrap height. All right, so that brings our stone up to here. Now the other option is you can tie to a slope, and let's give it 100%, and you can see what effect that has. It comes out here and then goes up at a 1-to-1. All right, so we'll go back to the wraparound. 8 inches. And now there's our stone. Now let's put one more subgrade under there, and we'll call that one, we'll actually continue the slope. We'll keep the offset at 0. So now we're down 10 inches. So we're going to go another 6 inches under the stone. So it'll be 16 inches for a distance of EOP plus, let's go ahead and make it 4. Actually, and then let's do that as a straight up. And we'll call this one just aggregate. It's a well-graded aggregate sub, or let's call it sub base. Okay, so now that sub base would be everything that, pulls out to here. You could make it, well, in fact, I think I'm going to change that to continue the slope. All right, so there it is. And it hits out to that distance, and then it just goes horizontally out to where it hits something there. Now, there's something wrong in the display out here. It should have, okay, when it's in cut, it does that. When it's in fill on both sides, it goes out to it. There we go. All right, so yeah, so let's actually, I'm going to bring that back to a straight up condition. See, there we go. All right, so we built our materials. We've got the asphalt top course, we've got the stone base, we've got the aggregate sub base, and all of that stuff is going to get accumulated and accounted for in our materials reports. Okay, so now we've got that. Let's save this, and we called that the 2-lane rural with curbs. And so now we need to put all this stuff together, and you could do that on the roads menu and say process road design. Now that is used to do a single road, but you can also do this road network. Let's go ahead and choose that. We'll make a new one. We'll call it Elm Estates, which is why our main road was called Elm Street. So that brings up this little guy over here, and this is the automatic way of doing all of this stuff. We could have started with this before we did any of this other stuff, and this is going to allow us to get to those editors like we saw there earlier. So let's look first at some settings. There's a couple things we need to set. We need to define the existing surface, which was that phase 6 original. I don't have a rock surface. I'm going to go every 25-foot interval. And when I get into the intersections, I may tone that down to say every 5 feet. I don't have any bridges. I'm not worried about that. Any special stations that you need to put a template drop at, you could do. The maximum offset to cut existing stations. Right now, I'll just leave it as whatever that is. And you can see in the reports, it will tell you if it exceeds that, you can come back and change that to pick up the rest of those materials. Process on the updated design. So if you change the profile or move the alignment to a different place, you can have it automatically recompute all of that stuff for you. I'm generally going to just leave it as prompting. So if I make a few changes, I may wait to make all the changes before I reprocess. And then I'm going to use the arc reduction settings from the system settings. I will tie to the existing ground. If you don't do that, the processing of the road will just do the road and the materials, but only out as far as the road is defined, out to that hinge point. When you do this tie to existing, it cuts in the cut and fill. Okay, and we're going to process intersection, connect the roads. Now, what do we do on the output options? Once it does this, it's going to give us the option to build this surface as we go along. So I'm going to say setup after I've checked that box. And you notice the same type of things from triangulate and contour. So I'm going to write to the triangulation file. I'm going to select that, and I'm going to call this roadway. It's my roadway, and it can be, I'm not calling it Elm Street because it can be multiple roads here. I'm just going to call that roadway. So it's going to be my roadway surface, and I'm going to, you can draw these as objects or draw the lines and the faces if you want to see 3D faces. I'm not going to do those. I will turn the contouring on. I'm going to put in a layer called C road cont-int, C road cont-idx for the index. I will draw the index contours. I'm at a 5-foot interval. 25s on my contours. I think that's probably going to match this drawing. We'll check it here in a minute and see. I'm going to go to my labels. I'm not going to do any labeling. I'll uncheck that. So I will draw the contours. I will write the file, none of those, and I'll say okay. Now, what do you want to output? Right here is either the top grade or a subgrade. You could do that as well. So we'd go all the way to the bottom of those subgrades and generate that as the excavated surface for you. You can tell it to draw these polylines in the drawing. We'll do that, show the disturbed area. And down here at the bottom, this output coordinates. When you do that, you can choose setup, and right now you can use it needs a coordinate file. So I'm going to call this one roadway 1 CRD. Let me make that a new one. And it should ask to override it. Yes. Okay. So now what do I want to kick out of that template? And you notice these are, well, I haven't defined the roads in the available template yet. So we'll come back to this. I'm going to do both sides, and I'm going to draw the points into my drawing. I'm going to include the station value in the description. And it's also include the offset. And the ones I want to bring out are my profile low station. I'll show you why in a minute. You can do all of these different ones. But I'm going to do my profile low stations. And I'll show you when we do that, why we're doing that. Right, so right now it's not going to give us anything because our profile is going to, there's no sag curves in it for now, but we'll do that in a minute. I've got some output file settings down here at the bottom where you can tell that you want to generate the existing sections, the final section. So that's going to create my cross sections for me. Here's my reporting options, how I want to do this. Report cut and fill end areas, any differences, report the subgrades and topsoil areas, report the cumulative cut and fill, set shrink and swell factors. My display options are just what I want to do when I select it over here is whether it's going to thicken it, highlight it with dashes, or do no selection. We'll just thicken it so you can see it. And now for some defaults, I've got some things that control intersecting streets and also controls as a road were to cross this road, it has to cross it as a vertical curve as we get up to it and come away from it. So I'm going to put in these 35-foot vertical curves to bring that up. So I'm not going to spend a lot of time. Again, this is mostly out of the civil design. Just take your defaults from there for now. And let's go back to the process options. And under this special stations, because we told it to process profile low points, you have to make sure you check on this profile station so we get them. Okay. Template transitions, if we change templates, it will drop a template drop right at those transition points, etc. We're not going to have any of that. This is all good. We will say, okay, we've now set up the settings, but we haven't added anything into our network yet. So let's go up here and choose the plus button to add. We just use the centerline file. We've already made that Elm Street. And so now there it is. And you see what it's doing is it's putting all of these things in these required files. I've got a centerline file, which I could go out and find a different one if I wanted. A design profile, we've already done that one, remember? So it's there. Now our template we just made, it doesn't know what to use. So I'm going to choose that template we just made, 2-lane rural. Open that, and now we also have these edit buttons to the right where we can was it that one, roadway one, I think. So that brings us back to our centerline editor, our profile. We hit that button and it goes right back to that profile editor. Now, watch what you can do here. Because you have defined a template, you can choose this button that says show sections. And that's going to show you, if I can get this to move out of the way. As I walk up and down the profile, you see how that cross-sectional template shows. And it not only that, but you see up here, it accumulates the cut and fill. So right now I'm at a 16,700 yards of cut and 4,500 yards of fill. So I'm a little bit out of whack. I could then, raise these up or do something with them to come up with something a little bit different. I can sort of use that to sort of estimate my balance. All right, I'm going to exit that and leave it alone. And again, you've got all kinds of super elevations and you can have different series of templates, all these different kinds of things. I've got some optional output files, my existing profiles, final sections, etc. All of these we'll leave alone. We'll say, okay. And now you see when I select this, it thickens that. It just in the marker in the drawing. And now I'm going to finally come down here and I'm going to choose this button on the left that says process, and you're going to watch it go through its machinations, and there it drew the contours. Excuse me, and this is my daylight line here, and there's my intersecting roadway contours. So we did have the right, it's a 5-foot interval. And so there it is. We've created that road design. We can now save this network definition, and we can even exit that and put it away for the time being. Let's now take a look at, and get my cursor back. Oh, come on. Well, if you haven't locked up, you can go and view that surface and you're going to see it, as it's computed the surface. Oh, for heaven's sake. Well, Now, here's the beauty of Carlson as far as being, let's see if I can get it to kick in here a minute. Just give it a second. But the beauty of having all these external files is I can recreate this very, very quickly. I could even go to a completely different file. In fact, I'm going to do that. Let's go up here. We'll kill this. Let's come back into it. Now I'm going to load this file up just so I can get a sense of those layers. So I will import the Civil 3D surface again. It's C topo major and V topo major. All right, so that's fine. Now I'm going to just erase everything out of there. And as if I were starting, I'm going to do a save as. I'm just going to call it road design. So it's completely empty of things, but it kept all the layer definitions and stuff that I had in there. So now go to surface. I'm going to contour from a 10 file. There's my original ground. None of that to worry about. Contour, I'm going to draw them. I'm going to put this on those existing C topo TC, what was it? C. I don't see them in there. All right, well, let's leave them as V's as that. I can even label it. Yeah, that'll work. I'll say okay. And now it's going through and it's, excuse me, creating those drawn contours. If I can get to it, there they are. I forgot to, I'm going to repeat that and set my interval to 5s instead of 1s. Making sure here that I erase those. All right, there they are. And there's my labels. All right. So I've got that, and I'm going to go ahead and draw the boundary as a 2D. All right, so all that's well and good. I'm now going to go to my centerline file, and I'm going to draw the centerline file. And while I'm at it, I'm going to label it. So I'll put it OK here and choose my Elm Street. And there you can see that one. And let's set my line type scale to 1. My MSLT scale is on. So now I've got my labeling, my curves, and that is on 0 center line. Let's make that Instead of red, we'll make it. And I'll turn my line weight on. There we go. So now I've got everything stationed. Excuse me, labeled. That's my roadway. And I'm going to also redefine CONT. What layer was that? Oh, be topo. So topo. So it'd be topo. So to make it white, we'll make it this color, and we'll make the intermediates this color. Get them sort of out of our way. I'm going to reverse that to 52. 254. There we go. All right, so they're going to sort of stay a little bit in the background. We could dash them to wherever we wanted. We could leave them alone. And now let's go back and reload our road network. There's our Elma States. Everything is as it was. We'll go ahead and process it. He says. Boy, it really did turn into Friday, didn't it? All right. Give it just a skosh time. Let's see. It's gonna. Someone didn't like. It's more quickly. I just want to get to the, once I process it, I want to get to the reports and show you that it's accumulated all those materials out of those cross sections, and it goes, section by section through that road design itself. And we'll leave the intersection for the civil class. We can worry about that at another point. Let's just make a new drawing. Let's go on a roadway. And say next. No. Roadway. Next, and we'll set that to that existing. We didn't have existing. We'll make it a new one. We'll call it roadway -01 to match our settings. We'll say next and come into that. We will now contour from a tin file. Let's see here. I need to be in getting started. Phase 6. Make sure we're still with the 5s. Yep. I'll say okay. There we are. We'll worry about all the particulars later. We'll draw the centerline file. Say okay and choose Elm Street. There it is, labeled. And now let's save this drawing. Let's go to roads, and this time I'm going to road network. Again, under getting started. I must have missed that getting started to save my drawing in. So now there's my road. Let's double check my settings. My existing surface is there. My outputs. Set up. Write the file getting started. Roadway. Come on. I probably should have done a whole Windows restart. It looks like that's what's going on. Just give it a minute. And go from there. I've got some kind of setting in that setup in that road network that apparently it doesn't like. So we'll run it a different way, but well, wait for it to respond. All right, last time I promise. I'm going to just use these already existing things that I've got in here. And you could do the same thing if you want to go to one that's already been pre-built for you and stored in there. I think it's available. Come on. All right, so if I open, and I'm going to go to my getting started, and I'm going to come down here and find my road net drawing. I think that will be the one I'm interested in. Yeah. So now this center line is called Main Street. All right. So if I open that network file that's been saved, I don't see one there. All right. Instead of using road network, let's go to process road design. This is much like road network, but it's for a single design. So here's now my center line is Main Street. I've got a design profile. Let me look at that profile to make sure there's nothing wrong with it. Yeah, it looks like it comes up and down. That's fine. And a design template series. I'm going to change that to use our, what did we have? Oh, I'm looking here at the wrong place. Let's go to getting started. We had our 2-lane rural. And that should, there's my existing section or my surface. And if I choose OK, and I'm going to triangulate and contour, and let's set the file to be roadway. And we'll draw the contours. Let's put the interval back to 5. No labels. That's all good. Say OK. And say OK. So now you see here's our results, and it's going to be our totals. Gives us a ratio, we got a disturbed area, and we've got curb on the left, curb on the right. There's your quantities. And even because we had defined that one earlier as a cost, as a material cost, it can accumulate that. We didn't assign costs to the other materials, but there's your top course asphalt, your stone, your sub base. You know, that's on the left side. This is the right side. And here it says the warning, the tie offset goes beyond the existing offset. So what you would do is come back to this, and in these output files, I think is where you would set let's see, design section will be Main Street. Finish grade. And our existing section would be Main Street, existing grade. It's removals. It's all good. Center of design profile template. And that should be okay. We'll say okay. And now we'll look for these offsets. Every 25 feet, maximum offset right here. Let's make it 150 feet instead. Template ID for the profile is going to follow the center. Shrink and swell. Everything's good to go with all of that. We'll set that back down to there a little bit. And it should work. We'll do okay. And again, you would see, oh, 100, it's a little bit more than, so we need a little bit, a little bit more than 150. Let's make it 165. So now it's going to reprocess and give us all those. Now we no longer have those warnings. And so it gives us all the accumulated materials within those end sections, to which I can go to my section and then edit my section file. If I look at my finished grade, and I'm going to get a reference section of the existing grade, and then just look through these. And there you can see as we step down through it, or we can drive through it in the 25 mile per hour driving. Yeah, screwed around with it up here and they didn't, it's not updating. the numbers are okay. It's just not updating the graphics here. So it's going through those individual stations, and I'd like to have it stop. Just wait for it to get to the end. There we go. Cancel that. Stop. On station rate 10 plus 50, 75, 11. Yeah, we go station by station. All right, so there we can see, and you can, come down to a particular location there. It says pretty much in, partially cut, partially fill. You can see how that works. We can cancel that and cancel this. And let's go ahead now and view that surface, which was called roadway. And you can see the various components of it here as it cut through there. You see there's your curbing, your lanes, the side slopes. There's a lot of, it cut through that hillside. If we looked at our, let me save this again. I don't think we can, let's see, output. Right now, output is up, so set slope, set layers, merge road with the existing. You could do that here as part of this operation. We'll just call it merged, except we'll spell it correctly. And there was one thing I wanted to do was in this triangulate and contour. In the road network, you're able to output the surface based on you can assign it colors. There's our quantities, materials and costs. There it's generated those and generated the design surface. And then when it finishes drawing those contours, if you should go through and change that profile then, and I'd like to take a look at that. If this one hangs, we're done, but if I make a new, and I look at my settings, existing surface was the phase 6 original. That should be okay. Output options, write the file, we'll call it roadway. Yeah, so replace it. Contouring, we'll draw them 5s, no labels. And right here, this surface to draw, if I set my colors and layers, and I can set that by grade ID, and I can use the sections, or I'm sorry, the template that we did to define those. Now we haven't set it up just yet. So we say, okay, for that. And I see what I had there. It took out the previous ones. That's okay. Let's process. In other words, well, gotta add a road. We'll choose a centerline file, and that was our main street that we have defined here. We'll use our design template, which is our 2-lane rural with curbs as our profile, and then good to go. We'll say okay. Let's save those settings, process that. So there it is. I'll look at my reports, my output. So here's all of that same type of stuff, and this goes section, station by station, and accumulates all of those and all of the various materials. And it's a little bit past that section. We're not worried about that. And there's the total curb, subgrade 1, subgrade 2, subgrade 3. That's top coat, asphalt, stone, and subbase. So it's generated those, and it's generated materials. And I'm going to go back to settings one more time now that we've processed it once. And we go to the output, this triangulate and contour. I'm going to surface to draw would be the roadway, but I'm going to set the colors and the layers. Now you see it's recognized the edge of pavement. I'm going to make it that gray. The curbs I'll keep cyan colored. My hinge grade, I'm going to make that more of this sort of lighter green, and I've got a darker green for those others and outsides. Was that the same? Other was 95. And then the outside, I'll make 95 also. Okay, save that. Oops, and then exit. Say okay, and now I'm going to save those settings, and I'll reprocess. And the reason I'm doing this is to show you what happens once that's done. You can look at reports again, everything I'm going to go ahead and exit that, and I'm going to view that surface, which was my roadway surface. And now you can see, let's display my contours every 5 feet. So you can see it's, with the exception of the fact I've got a little bit of bleed through there, but it assigned those colors based on those components of my template. If I'm there again, I just go to my main street, double click it, and looks like that's going to be the end of our section. But anyway, you get the idea. And so what you're going to do, instead of using that tool to design your road, which there's a lot of good things to help guide your designing, when you'd still set that up to where you tie these files together, and you would edit the centerline file or pick it from the drawing if it's drawn in the drawing, and create a centerline file for it. And the same thing with the profile. You would just go to that profile sheet and see what it looked like and create the road profile based on those numbers you see on that sheet. Associate that with the road, associate the template design, just like we did with the subgrades, tie it all together. And then if you had intersecting roads, let's say you're in a subdivision, you had another road to cross it, it would actually recognize that intersecting point and runs it all together as a single network and a single roadway construction effort. You can get your reports that handles everything about it. Okay, so with that being, what's going to happen here with this one, I'm not going to make you guys sit and watch. There's something that I think a good restart would fix me, but we're not going to take the extra time. We're already half hour over, so you guys are all going to get an extra hour in your PDHs, but unfortunately nobody really needs the credit on this thing at this stage, which is fine. You'll still get the credit. So anyway, that's the drink from the fire hydrant over 2 days. Hopefully everybody got some value from something out of this. I would hope so. I think you guys have all seen some tools that you can explore a little further. Understanding there's always little glitches and gotchas. So any questions on any particular thing, either that we've gone over or just anything that occurred to you? Everybody good?
Yeah, been good.
Yeah,
Okay,
pretty good.
All right.
Yep.
Well, guess what, guys? It's not only 5 o'clock somewhere, it's 5 o'clock here. Now, Ryan, you're gonna have to start drinking early, but that's okay. It's Friday.
Sounds
And,
good to me.
and since from your perspective, it is 5 o'clock somewhere, and I've got proof of it here looking at my clock, I'd say you're free to go. All right. All right. So I'm going to stop our recording.